We finished the last topic in our class, that was measurements, and this is our next topic, further solving equations and inequalities. Keywords: intersection, simultaneous, linear equation, region, linear programming, quadratic. I hope you're familiar with most of them.
I know intersection. I know linear inequalities. Simultaneous, I know it happens at the same time. That's all I
That
know about simultaneous. And quadratic, yeah, quadratic I know. And then linear programming and region, I don't know.
okay. Simultaneous, basically, we that is it, which happens side by side, and we are going to solve those simultaneous equations to find the point of intersection, the common point between them. And then the region is the area. Whenever we'll be talking about inequalities, we'll be talking about the areas. Either it is a line or it is an area. Suppose I draw the line and I tell them to stay on the line, or maybe I draw a line and say stay on the left side of the line. So that's the area.
Oh, that
Sometimes,
could be on. Okay.
sometimes we do have the limit on coastal regions. For example, the Coast Guard would tell you that stay within 20 feet of the coastline, because after that it is maybe more shallow. Then linear programming is something again related to straight lines. For example, we would have any case. Suppose I'm talking about a car industry who prepares a car to be sold, and we are talking about the expenses. So we can draw that linear programming according to number of cars and production cost and all that. Then quadratic is definitely curve with one turning point, which could be either maximum or which could be minimum point. So let's start with the simple ones first. This is what we've already covered. Removing the brackets and solving, following the mass rule. If you're talking about inequalities, having a look at these fours quickly. Do we understand this first term? X is less than 12.
Mhm.
It is on left and 12 is not included. X greater than 12, again to right, and 12 is not included. When we talk about the third one, it is to left, X is less than and equal to. The difference is
Circle. That
the
is called,
circle. Yeah, the
which means,
circle is filled this time.
which
And
means
I think
included, right?
that is included. Yes. And the fourth one says greater than and equal to. And I think there's been a printing error. This needs to be exactly above 12
Mhm.
because that is included. Simultaneous linear equations. I'll start with an example, then we'll come back to this and showing you the relationship between what what they meant by linear programming. For example, we take this case, a very simple example. Let's say we are preparing toy cars, and let's say Mr. ABC owns that business, and he is definitely paying some rent and some wages. So let's say this is $50, this is $100. Let's say he's already paying $100, even if he makes zero sales. Now, when he's preparing some cars, these were zero cars, this is one, this is two, this is three, this is four. So when we prepare those cars, we definitely buy something. We need raw material, maybe plastic, maybe motor, maybe engine, maybe wires. So let's say each car is we're purchasing raw materials for $10 each. So one car would be prepared in $10, but he's already paying those $100. So this will cost him $110. Do you agree?
Yes.
Then when we talk about the second car, another 10, that means two
120.
cars and oh, that's right, 120. So I'm getting this linear trend. This is known as linear programming. Whenever we are talking about four, this is 5, 6, 7, 8, 9, and 10. So 10 cars would mean 100 plus 100 is 200. So that would be $200 cost. Now, when we are selling it, let's say we sell one car for $30. So one for 30, two for 60, three for 90. Hmm, this should be a little below than that. 60, three for 90, four is 120, and so on. So we have these two relationships. This was my cost. This is my selling price, and the difference would give me the profit. And this point right here would tell me that this is the break-even point. I need to sell minimum of these number of cars in order to recover the cost. So this is point of intersection, and we are solving simultaneously. How simultaneously? Increasing the number of cars. The blue line is also rising. The green line is also rising, but at a different rate. And there's only one point where they will be equal to each other. Getting it?
Mm-hmm.
If I may write the equations, the one in blue will look like this. Y is equals to the cost was 10 per unit and the fixed cost was 100. Y equals mx plus c. And the one in green will look like this. Y is equals to 30x. So there are two different ways. One is graphically, which we just did. We will draw this and see where it intersects. The second is we solve them simultaneously. This is equation one and this is equation two. I'm going to substitute in these in each other. Let me say the first one is y is equals to 10x plus 100. May I substitute 30x at this place? This is that instant when they are exactly equal to each other. I can say y is equal to y at this point of intersection. If I say this is y1, this is y2, so I can say y1 is equal to y2 at this point, only at this point. And definitely x would also be equal. So when we're solving this, this goes on the other side. That's 20x is equals to 100 and x is equals to 5.
So this only works when we have one line that's directly equal to 30x and the other line that's wait, no, it can also work with equations. No. Yeah.
Yeah, these are equations.
Yes.
You're right, these are
I
equations.
mean, like I was confused about the y equals to 30x because it's like easily you can just move it to the other side, but you can also do that with equations. So
Yes, we will make it subject. We'll rearrange it and then substitute. Solving equations, we have two different methods. I did it with substitution, and there's another method known as elimination. We'll go through both of them. So simultaneous linear equations, graphical solution of simultaneous linear equations. So once we have these two equations, let's say the first one is x plus y equals 8, and second is 4x plus 2y equals 26. Now this could be for any system. Like we just created one for making a toy car and selling them. So we are not always interested what the system is for, but we need to find the solution. So x plus y is equals to 8. Do you remember how we used to draw the graphs? If I
Mhm.
just bring this out, may I write the first one as y is equals to 8 minus x. So this is x, and let's say we are working for 0, 1, 2, 3, 4. This is just for the sake of the question and to fulfill the demand of the question. Or else we know that in linear, 2 points are also enough to draw the graph. Now, when I plug in 0, 8 minus 0 is 8. 8 minus 1 is 7. 8 minus 2 is 6. 5, 4, 5, 6, 7, and 8. 8 minus 5, 3, 2, 1, and 0. So I now know that x0, y8. This is the first point. X1, y7. This is the second point. Because this is linear, I can use these 2 points, a ruler and a pencil, to draw the straight line. So first one would be done in this way. For the second one, again, rearranging always helps. So I can see this is 2y is equal to 26 minus 4x. 2y is equals to 26 minus 4x, then making y the subject, y is equals to 26 minus 4x by 2. And luckily both of them are even, so 13 minus 2x. Even if it wouldn't have been even, we'll just write it and make y the subject. So 13 minus 2x. So this is 0, 1, 2, 3, 4, 5, 6, 7, and 8. So when x is 0, 13 minus 0 is 13. When x is 1, 13 minus 2 is 11. 2 is, that is 4. 3, 2 times is 6. So this is 7. 5, 3, 1. And 7. 2 times is 14. That would be minus 1 and so on. But the question, I think, is not requiring the negative side. So x0, y13. 13 is not there. So I'm in the y-axis. So I'm just coming at this point, x3, y7. So this is x3, this is y7. Let us see this point, x5, y3 is x5, y3. So we just draw that line. And then point of intersection could clearly be seen that we are having it at x5, y3. This happens, x5, y3 happens in both of these. This could be integer, this could be in decimals. But it is the point of intersection. And this method is known as graphical method.
So solving from a graph, basically.
Yes, this first method is known as graphical method. The second method, when we equate these equations, is known as solving simultaneous equations by substitution. Because substituted 30x in y. And there's one more method which is known as elimination. I'll come to that once we polish the concept of these two. The question would clearly state what it requires. The boundary is between the graphical method and the other. So when it says by drawing the graph, he's very clear he needs to see it by the graphical method. By drawing the graph of each of the following equations on the same pair of x's, find the simultaneous equations. Find the simultaneous solution to the equations. So x minus 3y is equals to 6.
So we can do
And
y equals to 6 plus 8x. I mean, no,
y
it has to be x. Yeah, 3y equals to 6 plus x.
minus 6. Okay, 3y, or you're taking it on that side. So there you need to change the sign of 6 as well, if you're taking y on the other side.
So negative 6 plus x.
Yes. And then y is equals to minus 2 plus x by 3. So I can see the gradient is 1 by 3 and y-intercept is minus 2. Because this is a worked example, so I know this is the line. Secondly, 2x plus y is equals to 5. If I make y the subject, that is 5 minus 2x. We can see the gradient is minus 2. Remember coordinate geometry? And y-intercept is 5. So again, this is that equation. We have these two equations. And how do we draw them? Now see, in this question, there's no limit, such as this one, that draw it from 0 to 8. There's no limit. So we can choose for ourselves and 0, 1, 2, anything. Because it is a straight line, I just need two perfect points. So if I use 0 in this y is equal to 5 minus 2x, when I use x is equals to 0, substitute it, I get y is equals to 5. When we use x is equals to 1, I can see that this is 5 minus 2, that is 3. So x0, y5 and x1, y3. These are good points. These are not in decimals. So I'll use these two. I'm approving these for myself and using them x0, y5, x1, y3, and then I'll draw this straight line. Now coming on to the next equation. You see, this is y is equals to minus 2 plus x by 3. There's no issue when I substitute 0. So x is equals to 0, y is equals to minus 2. That's a very good point. Both are integers. But 1 by 3 minus 2, that's giving me minus 5 by 3. So I'm not using it. Are you getting the point?
So
When
it's
I substitute
point that's
1,
basically.
yeah, I'm avoiding decimals. So this is not a good point. That is correct, but that's not good. Where will I mark that point? It will change my line slightly up and down. Okay. So now I see before substituting, because we are practicing it. So I would know that 2 is also going to give me a fraction. So I'll use either 0, 3, 6, 9, 12, anything which is a multiple of 3. So if we substitute 3 by 3 is 1. 1 minus 2 is minus 1. So at x3, y is minus 1. So again, that's a perfect point. Both are integers. Then we can draw this straight line and find the point where both of them intersect. Any confusion?
No.
Okay, I'm going to convert this viewing option to squares and try and use them as my grid. It's too small. This one's much better. Okay, the question is also telling us what values do we need. So for now, I'm selecting this B because I can see that the demand is too less. The first one is from 0 to 11 and 0 to 10. That would be too many boxes to fit in this screen. I'm doing it for B part. And the equations are x minus y is equals to minus 1. Second equation is 2x plus y is equals to 4. And the question is giving me hint that we need x from minus 2 to 3. And we need y from 0 to 4. So this is my data. On left hand side, I'm doing my rough working. On right hand side, I'll draw that graph. So for the first equation, may I write y is equals to x plus 1?
Yes.
So this is my x, and that's y. We know we are moving from minus 2 to 3. Minus 2, minus 1, 0, 1, 2, and 3. So substituting directly, minus 2 plus 1 is minus 1, minus 1, 0, 0 is 1, 1, 2, 2, 3, and 4. Looking at the second equation, that is y is equals to 4 minus 2x. Using the same box, because we are dealing with same x, getting different y. Now I'm substituting -2. -2 into -2 is +4, 4 is 8. -1, 6, 0 is 4, 1 is 2, 2 is 0, and 3 2 times -2. So now I have these two sets, and let's fulfill the demand of the question. So let's say this is my Cartesian plane. I'm labeling them -1, -2, negative x-axis. This is 1, 2, and 3, positive x-axis. On y-axis, it is from 0 to 4, 1, 2, 3, 4. So first one in red, x -2, y -1, -1, -2, x -2, y -1, x -1, y 0, x 0, y 1. I'm already getting that trend. So this is my graph of x minus y is equal to -1. Second graph, x -2, y 8. First of all, examiner is not interested, so I can only draw these values. X 0, y 4, 1, 2, 3, 1, 2, 3, 4. Even if we draw all of these, that is going to be correct. I'll show you. X 0, y 4, then x 1, y 2. Then we have x 2 and y 0, x 3 and y -2. So I'm getting this trend that in every 1 unit increase in x, y is falling by 2 units.
Do we
So if I
include
just,
-2?
please say that again.
Do we include the -2?
Yeah, we can do that. There's no issue.
But this is 0 to 4.
Yeah, just look at this. If I extend this line, there's no harm to the question.
Mhm. We just have to mark the points which are up to that, right? Or no?
Yes. Yeah, like I'm ignoring the other points because before solving, how would I know that y will be more than 4?
Mhm.
So I just used x -2, which was definitely included. And at x -2, I'm getting a positive 8. But after that, I now have my raw data. And when we draw, I could see that there's no need. The hint is to facilitate us. See, the point of intersection is also within the given limits. So can we see where the point of intersection is? So this is x1 and y2. So this was a complete graphical method. So this particular one, this is x1 and y2. This is the solution. Each one of this question, the method is same. Question 2, use the graphs supplied to find the solution to the following pair of simultaneous equations.
It's giving it to us.
Sorry?
It's giving it to us.
Yeah. This one on the left. Like all the lines are already drawn for us. In question 1, we needed to draw the line first, and then we see the point of intersection. So for question number 2, y is equal to x and y is equal to -2. First find these two lines. Y is equal to x and y is equal to -2. Can you locate them?
And then the intersection is at -2 and then also -2.
Very good. Second one, y is equal to x and y is equal to 3x minus x.
It's at 3, 3.
3, 3, yes. 3, comma 3. C part. Y is equals to 4 minus 2x and y is equal to -2.
Um, So it's at 2,
I'm looking at a different point.
It's on the blue, right?
Yeah, blue one. Blue and red.
Mhm.
This point. This is the line. Y is equals to 4 minus 2x.
It
If
feels
you can read it, if you can, like, you see this blue one at the right bottom. Even if it's like blurry, what we can see is 4 minus 2x. So intercept has to be 4 and gradient has to be negative. So this is the only one which is intersecting at 4. So the blue one and y is equal to minus 2, the red, the one in red.
so 3 minus 2.
X3 y minus 2. D part y is equals to 4 minus 2x and y is equals to 7x, y plus 7x plus 1.
So it's 1, no, negative 1, 6.
So this is the one in yellow and blue, very good, negative 1 and 6. Y is equals to minus 2 and the yellow one again.
It's at,
Now
it's not
see, may I call it?
back on it, but
This
it's
is a
at,
decimal section.
yeah.
So y is already minus 2. Now this is what graphical solutions are. From the graph, I have to read this, and both of us know that I'm not clear what it is. If it is between that one box, I could say that is half of it, or 0.25 or 0.75. Now, what do we do? I'm very sure that y is minus 2. So, may I just use this equation and substitute y minus 2? So, this is my rough work. This is 7x minus 1 is equals to this, and x is equals to 1 by 7. So, I'll write 1 by 7 in here. X is 1 by 7, y is minus 2.
Okay.
Last one. Y is equals to x and 4 minus 2x.
It's also not really,
Right here.
and it's at 1 point, it's at
Okay, let's make a guess and then we'll solve them algebraically.
maybe 1.45.
1.4 or 1.3 something.
Yeah. And
So
then
now let's see.
y is at 1.5, I'm guessing.
Both same because it is y is equal to x.
So it has to be the same. So 1.4 for both.
Okay, now let's substitute this x here. Can we do that? Because y is equal to x. So x is equals to 4 minus 2x. Bringing x on the left hand side is 3x is equals to 4. So x is equals to 4 by 3. That is 1.33. So I can write x is 4 by 3 and y is 4 by 3. And that was the rough working. Now, what will be an exam? Do we do this rough working or we read off the exam, the graph paper? We will read it off the graph paper. In exam, graph paper is not like this. We do have small boxes in millimeters. So we'll be able to read it up to the 1 decimal place. Question number 3. For each pair of equation, find 3 points on each line and draw the graph on paper. You see, he's making it easier. So 3 points, we don't need to draw eight points for both of these lines and draw the graphs on paper. Use your graphs to estimate the solution of, you see this word estimate. You don't have to be exact. You'll just read it off the graph, whatever it looks like, and it needs to be correct near to half box. The solution of each pair of simultaneous equation So I see that this is 3y is equal to minus 4x plus 3 and y is equal to minus 4 by 3x plus 1. We are doing simultaneous equations, but we've already done coordinate geometry. Having said that, may we make a guess that this is negative gradient and y-intercept is positive 1? So I'm just making a sketch for myself that gradient is negative and which is more than 1. So it should look like this. It should intersect at y1 and negative 4 by 3. Second line is x is equals to 2y plus 1. X is equals to 2y plus 1. I'm rearranging it. 2y is equals to 1 minus x and y is equals to 1 by 2 minus x by 2. Now I see that the y-intercept is positive 1 by 2 and gradient is still negative, which is less than 1. So roughly it should look like this. Now, why am I doing this? To have an idea where will the point of intersection lie. So it is clear that it is on the positive side. So I may draw it for x0, x1, x2. Equations are 3y is equals to minus 4x plus 3, which makes it y is equal to minus 4 by 3x plus 1, x and y at 0, this is 1. I know at 1 this will be decimal something, so I'm taking multiples of 3. So when I take 3, this is 3, 3 minus 4, 1 minus 3, and another point 6. 6 by 3 is 2, minus 8, minus 7. And the second equation, x is equals to 2y plus 1, this is x, and y is equals to 1 by 2 minus x by 2. And this is y. So at 0, this is 1 by 2. Although that is not integer, but that's a very good point. That is exactly between two boxes. So second value, I'm taking multiples of 2. So if I take 2, 2 by 2 is minus 1. This gives me negative 1 by 2 and 4 is 2. 4 minus half is 3.5. x4, 4 by 2 is 2. This is 1 by 3 by 2, 1.5. One thing we already knew that the point of intersection is to right of the y-axis. So this is x0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And on the other side, this is 1, 2, 3. And negative side is minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. So first one, x0, y1, x3, y1, 2, 3, minus 3, and x6, y minus 7. Second, x0, y1 by 2, x2, 1, 2, y negative half, x4, y3 by 2 is 1.5. So we get these 3 points and we draw the line. So this is the point of intersection. So it looks like x
5, 0.75.
0.75 and y appears like 0.2 something. Let me also draw it here. This would be very clear when we are doing like with the pencil and scale. 3y is equal to minus 4x plus 3. Py is equals to minus 4x plus 3. So one equation, and second is x is equals to 2y plus 1. What just happened? X is equals to 2y plus 1. Oh, negative sign, mistake. This was blunder. X minus 1 is equals to 2y, and x by 2 minus 1 by 2 is equals to y. Changing it quickly. When x is 0, this is negative 1 by 2. When x is 2, 1 minus 1 by 2 is plus half. And when x is 4 by 2 is 2, this is y is 3 by 2. Oh, that was positive. I should have got it at that point. So x0, y minus 1 by 2, x2, y positive 1 by 2, and x4, y positive 3 by 2. So this. And let's see it over here, what the point of intersection is. So point is 0.8 and negative 0.09. So that's easy to read on the graph page.
Could you go back to the part where that paper? So when we're doing it, so 2 is at positive 1 over 2 and 0 is at negative 1 over 2. And when you drew it, can you go back to the sketch? No, not a GeoGebra.
This one,
So
that
I
was a mistake rearranging it. Like this was the mistake. I
so
had to take 1 on the other side and make y the subject. So that was positive x and negative 1.
mhm.
This is the mistake. I'll do it again. X is equals to 2y plus 1. To make y the subject, x minus 1 equals 2y. And now making y alone is x by 2 minus 1 by 2 is equals to y. This was the correct equation.
Okay.
So y is equals to x by 2 minus 1 by 2. So at 0, we have negative 1 by 2. And when we substitute 2, 2 by 2 is 1. 1 minus half is positive half. Then 4, 4 by 2 is 2. 2 minus half is positive 1.5. So the point is sketching and then looking at the point of intersection. Number 4, explain why the graphical method does not always give an accurate and correct answer. So
Because
that
of
is right in front of us. Say it.
because of something like human error where it might not show exactly what points are on it so that we can exactly point it out like for each points.
Yeah, we would say that these are not integers. Like during exam,
That's no. So
uh, we should not say that there's human error. Like we are giving our best during exam. So yes, it is either a decimal number or not exactly on the given marked boxes. How can you check whether the solution you obtained graphically is correct or not? Now let me go back.
through the what was it? Simultaneous equations. So solving it
That,
through
that's a second method. That's a second method. There's an easier solution to it. Look at this worked example. We worked out that x3 and y minus 1 was the solution. x3, y minus 1 was the solution, right? The point of intersection is right in front of you. Can you see that?
Yes.
Now, how do we know that this is correct? So we plug it back in the given equations. My first equation is x minus 3y equals to 6.
Mm-hmm.
X minus 3y is equals to 6. So I'm going to put x 3 and y as minus 1. So see, 3 plus 3 is equal to 6. 6 is equal to 6. That's correct. Now I'm going to check the same point in the second equation as well. So there is 2x plus y is equals to 5. So 2 into 3 minus 1 is equal to 5. 2, 3 times 6 minus 1 equals 5. 5 equals 5. Again correct. So I can say left hand side is equal to right hand side. We plug this back one way. The second way is just plug it half. Let me show you. So the solution was x3, y minus 1. So I'm using only x3. X minus 3y is equal to 6. I'm using only x. So 3 minus 3y is equal to 6. Taking 3 on the other side, minus 3y is equal to 6 minus 3 is 3. Y is equal to 3 by minus 3. Y is equal to minus 1. So the graph says when x is 3, y is minus 1. And the equation says when x is 3, y is minus 1. Does it make sense?
So we're plugging it in.
Yes. And we do it in both the equations, not one. So 2x plus y is equals to 5. Now again, I'm plugging in only x and looking what y turns out to be. So 6 plus y is equals to 5. Y is equals to 5 minus 6. Y is equal to minus 1. So see, when x is 3, y is minus 1. So yes. So how do we check it? We substitute the values in the given equation. You see these values? Question number 2. Let's quickly check for this t part. When x is minus 1, first equation, y is equal to 4 minus 2 into minus 1. 4 plus 2, 6. Is it correct?
Yes.
And second equation again. So y plus 7x plus 1 equal to 0. When x is minus 1, y plus 7 into minus 1 plus 1 is equals to 0. So y minus 7 plus 1 equals to 0, y minus 6 is equals to 0, and y is equal to 6. So how do we check? We substitute the value in the given equations. Either one of the component or both. When we put both, we'll get left hand side equals right hand side. And when we substitute one, we'll definitely get the other answer. And we can do it with y or x. That is your choice. Now this was completely graphical method. So drawing the graph and looking at the page and seeing where it intersects. Algebraic solution of simultaneous linear equations. And these are the two methods which I was talking about. One is substitution, the other is elimination. So let me write some easy equations for us to discuss, and then we'll move on to the exercise. Equations, let's say the equation is y is equals to 2x plus 4. And second equation is y is equals to minus 2x plus 8. So first method, substitution. Now we're not doing graphical method. We're not sketching them. We're not plotting them. Substituting. I am substituting the first equation and second equation. I've written them in a way that y is already the subject.
So 2x plus 4 equals to negative 2x plus 8.
2x plus 4 is equals to negative 2x plus 8, right? So now we can solve for x.
So x is 1, yes.
X is 1. Now we make a choice. Substitute this x in first equation or second equation.
First one.
First one. So put in equation 1. So y is equals to 2x plus 4.
Y
So
is
2
equal.
into 1 plus 4 and y is equals to 6. So my answer is 1 comma 6. Question is complete. This was by substitution. Now same question with elimination. Y is equals to 2x plus 4 and y is equal to minus 2x plus 8. Same question with elimination. Now what is eliminating? Eliminating is getting rid of one of the variable. So how do we do that? We add both of these equations or we subtract both of these equations. So if I just write these equations like this, y is equals to 2x plus 4, which was equation 1, and y is equal to minus 2x plus 8, which was equation 2. I can see that if I add them, I'll get rid of x. So adding both of these equations is 2y is equals to, this is equals to 12.
And subtracting them would give us y. No,
Uh,
subtracting them
Subtracting
would give us
would get rid of y.
and it'd give us,
So
yeah.
this is y equals to 6. Only this cancellation or getting rid of one of the variable is known as eliminating one of the variable. Hence the name is elimination. So when y is 6, now again we have to make a choice equation 1 or 2. Put in equation any one. Let's say 1 again. So y is equals to 2x plus 4. We know y is 6. 6 is equals to 2x plus 4. 2 is equals to 2x. X is equals to 1. So x1 and y6. So 1 6 by elimination and 1 6 by substitution. Now these were simple because I myself took as x 2x and minus 2x. Now let's see for this equation. You see all the constants are different. There's 3 with x, 4 with x, minus 2 with y, and plus 1 with y. So this is going to be interesting. Sample question. And we have 3x minus 2y is equals to 29 is the first equation. And 4x plus y is equal to 24 is the second equation. Now let's do it with substitution first. Now what do we do? Whenever we are solving them and rearranging them, we keep numbering them for ease. Now, you know that we have to substitute one of the equations in the second one. Just look at the equation and what do you think is easy to make subject, x or y?
Y.
That's right. If I will make x the subject, I know I'll get that in a fraction. And which one is easy, 1 or 2, if you are making y the subject?
Mm.
2. So I'll write from equation 2, 4x plus y is equals to 24. And when we make y this subject, this is it. I'm naming it as 3. Now we did it from equation 2. Where should we substitute it?
Into equation 1.
Very good. Put in equation 1 because substituting 2 in 2 will not lead us anywhere.
So we also have to substitute the y. I mean, like, move the y to the other side for equation 1.
No
To
need. That is just some extra steps, but that's not wrong. Put equation 3 in equation 1. So I'm copying equation 1 first. 3x minus 2y is equal to 29. So when substituting, 3x is equals to 20. Sorry, this was minus 2 and y is 24 minus 4x is equals to 29. So that's just luckily if we have y equals y, we can substitute them. So we substituted one y in the other. Now 3x minus 48 plus 8x is equals to 29. This is 11x, 8. What did I do? This was
40.
2, 48. So 8, 9, 10, 11. And on the other side, that is 48 plus 29. 11x is equals to 29 plus 48 is 77. So x is equals to 7. Now put in equation. Mathematically, you can put this in any equation, you will get correct answer. But where should I substitute it? 1, 2, or 3?
2.
That's right. That's not wrong. What about 3? Because we are finding y. And in equation 3, y is already the subject. So in equation 3, y is equals to 24 minus 4x. 24 minus 4 into 7. 7 4 times is 28 and minus 4. So answer is 7 comma minus 4. This was substitution. Is substitution clear?
Yes.
Now we do the same question with elimination. Let me just highlight the answer. 7 minus 4y and x7 minus 4. Copying the question. Elimination. So this is 3x minus 2y is equals to 29 and 4x plus y is equal to 24. Now, what was the main aim in elimination?
Get 2 same ones. So we can times the bottom equation by -2.
Very good. What if I just keep it positive too?
Oh yeah, that one could work as well.
Negative 2 is still correct, but at that point we will be subtracting it. So if I'm keeping it positive 2, I'll just be adding them. So I can rewrite these equations as 4 2 times is 8x plus 2y equals 48 and copying the first one. 3x minus 2y is equals to 29 and I'll write this adding both of them.
And then yes, x equals to 7.
Very nice. And then use any equation. And I'm just going to write an example question and we'll change them for elimination. So if it is 3x plus 4y is equals to 9, I'm just writing it at random. If we solve them, we may get answers in decimals, fractions. 2x minus 5y equals 12. Now, if we have to do it by elimination, what would you do?
I would times the bottom one by 1.5 to get the 3x.
Very nice. So in that case, I'll just change it to 7. Now what? I actually had something in mind. I want to deliver that to you. I've changed that 2 with 7
Why?
to rethink that what will we do in this case.
Oh, okay. We can,
We can do it to both of them.
yes.
First of all, decide what do you want to get rid of, x or
Well,
y?
so we can like times the 3x plus 4y equals to 9 by 7.
Yes,
The bottom by 3.
that's right. So this is 7 and this is 3. Now you do know that both of them will be positive.
Mhm.
Either we change the sign right here of one of them or we just write it. So this is 321x, 7 4 times is 28, y, and 7 9 times is 63. So 21x again minus 15y is equals to 12, 3 times 36. Now we're subtracting it. So we change all these signs. So get rid of this. And 28 plus 15 is 43y is equals to 63 minus 36 is 27. So y is equals to 27 by 43. And we can substitute it in any of the equation to get x. So this was substitution and elimination. Worked examples, all of these are simple. Let's jump to the exercise. Okay. So the question says solve for x and y by substitution. We'll first do 2 to 3 examples with the option given. Use the method you find easiest. Okay. So the best way to decide this, can you read this statement for question 3?
Mhm. Solve simultaneously. Use the method you find easiest. Check all solutions.
So we have to see either substitution or elimination is easy. If I just look at the question 2a, we can clearly see that we can get rid of y without doing anything. And so is in 3b, we can get rid of x. 3c, we can get rid of x, right? So
Yes.
just at a glance, we know that elimination is easy in these questions. What will we do for practice? We will do any question we solve by both the methods. That will do two things. One, we'll get same answers and we'll know that the question is correct. Secondly, once we are doing the same question with both methods, it would be easy for us to decide in exam. If I look at question 3H part, what do you see? Elimination or substitution?
Substitution.
Very good. G part.
Elimination. Because we
Very
can,
good.
yeah.
You're eliminating y's in them.
Mhm.
So we'll solve the question with both the methods, like in our free time. Now let's just follow the instructions of the question for now. It says solve for x and y by substitution. Check each solution. Some copying question number 1E. Exercise 14.2, question 1, part E. It says 3x minus 2 is equals to minus 2y. Second equation is 2x minus y is equals to minus 8. And we're doing substitution.
So x equals to 2.
Very good. 1, 2.
What?
From equation 2, 2x plus
Oh,
8
you
is equal.
chose E. Um,
Yeah.
I did the one for 1A. So
A was easier. I'm getting x minus 2 and I'm working for y. I'm getting x minus 2 and y 4. And the second part requirement of this question is to check my answers. And how do we check them? We substitute them in both the equations. So 3x minus 2 is equal to minus 2y. And my answer was minus 2, 4. Minus 2 and 4. So minus 6 minus 2 minus 8 equals minus 8. And second equation is 2x minus y equals minus 8. X is minus 2, y is positive 4. So minus 4, minus 4, minus 8 equals minus 8. Check that. So that was substitution. Any issues?
could you scroll up? I just want to copy them down. Okay.
Now elimination. Let's make a choice. All of these are pretty easy choices. Let's solve this I part. Six x minus 5y equals 9 and 2x plus 5y equals 23. I'm getting x4 and y3.
Yes, y equals to 3, and then, yes, x4, and then y3, yes.
So now we know what substitution is and what elimination is. We'll solve simultaneously. Okay, let's practice some questions from the third one. Other than these two, make a choice out of these six.
Okay,
Sorry,
okay,
I didn't get it again. This is JKLMNO.
okay.
Okay, okay. So, and how will you do this?
Mm. Substitution. I mean, elimination. It's easier
Okay,
with two y's.
this is you're doing it with elimination. I'll do it with the other method and we'll compare our answers. Okay,
Okay.
so this is our question. 10x is equals to 2 minus 2y, or 2y is equals to 7x minus 1. Let me know when you've noted it.
Mm-hmm. Okay.
Okay. So you're doing elimination.
Yes.
I'm doing it with substitution. I'm getting 1 and minus 4.
Sorry, I wasn't getting the same thing because so I'm just gonna like retry it.
Take your time.
I don't know why, but for x, I'm getting 3/17.
3/17. Maybe you're making a mistake with that sign of 10 and 7. Let me copy that.
I think so, yeah. I think I needed to add the negative sign. Negative 7x equals to that. Okay. So 3x equals to
Yes.
so 1. X is 1.
X is 1, yes. And Y?
Four?
Y 4. Minus 4.
Oh, sorry. I forgot to carry the negative on a negative 2. So yes, minus 4.
Okay. First thing was to find X and Y. Second thing is to make the check. So we will now substitute this x1 and y minus 4 in both the equations and see if left hand side is equal to right hand side. And elimination for this question was a good choice. Definitely that depends on personal practice. And like I did it in my time, then I'm doing it with different students. So somehow that is like increasing my practice. Students also share their experiences. You see, when I saw these two equations, you chose elimination because of these two y's, then that's a very good choice. And when I'm doing for substitution, you see, I just made this 2y the subject and not y.
Mhm.
And directly substituted this 2y in the other equation. That reduced my number of steps. Luckily, there was this option. 2y could be substituted with 2y.
Mhm.
If I would have gone with making y the subject, this would be y is equals to 2 minus 10x by 2, and then simplifying y is equals to 1 minus 5x. That will take some more steps. So whatever we choose, substitution or elimination, both are correct. We just have to fulfill the demand of the question. As in, the first part says solve by substitutions, so no choice. Second, by elimination, no choice. Third is use any method. We can choose any method. Okay, I'll share this with you, or
Should I
you can,
screenshot it?
yeah, sure, but I'll still share it with you with answers.
Okay. Okay,
And
yeah.
these are 15 questions, which is somehow a lot. And you can make random choices. I'll share all these questions with answers. But whatever you do the same question with both the methods.
At least how many questions would you like me to answer?
3.
Only?
Like if you would like me to choose why, so they'll make it 6 actually.
Well, yeah.
Like you're solving the first question with substitution and elimination.
Okay.
And there's a check as well. So we do check our answer is correct or not. How? We substitute x and y in both these equations. So one thing is substitution and elimination both. Secondly, when you're solving it and you're enjoying your task, you may do as many as you wish, but minimum of three will fulfill it because you're actually doing them as six.
Can you choose which ones I should do? As in like three?
Uh, okay, I'll just go over these and write it in the file.
Okay.
And I should email you as well.
Yes.
Okay, sure. I'll do it soon in few minutes.
Okay, thank you.
I shared these questions with you and have a look at this question number 5. It says solve each of the pair of equations simultaneously. Now the question never tells you which method you should use. So we either choose elimination or we choose substitution, that is up to us. So if I just look at this E part, if I look at this, I may go for elimination because I can see both x's are having coefficient of 1. When I'll rearrange, bring it to left-hand side in the second equation, I'll get negative x and it would be eliminated. Even if I want to eliminate y, I can do that. And so is the case in G part. I can multiply the first one with 3 and get same coefficients for x, or multiply with 4 and get same coefficients for y. But when we talk about the ones with fractions, the better choice is substitution. So there's no restriction. Let's try one of these. Let's try I part and then we'll move on to these statement questions. This says 3x by 7 minus 2y by 13 is equal to 5, equation 1, and x plus 1 by 3y is equals to 3 by 5, equation 2. So what are you thinking, elimination or substitution?
Substitution.
Okay, I'll do it with elimination on purpose. So we can just compare it. May I go full screen? Have you noted the question?
Ben konuşuyorum, 1 saat sonra bana cevap veriyor. 1 saate ulaşıyor. Aradan az zaman geçiyor. Bir süre ondan sonra bana ulaşıyor. Could you help me with this one? Because
Yeah, I'm just going through the check.
okay.
I'll be uh, first check is done, and the second one. Okay, so this is elimination. Let's discuss this and then I'll come to substitution and we'll figure out where the issue is. First equation and second equation. So I had this choice that I can multiply 3 by 7 to make the coefficient of x same. Why was be complicated in this case? Because for this, I should multiply with 1 by 3 and 2 by 13 this way to get y same. That would be very much complicated. So when we multiplied, I got the coefficient of x same, eliminated them, and on purpose used this negative sign. So I can simply add them and get rid of x. Or else we could have just subtracted. And meanwhile, I was using calculator. 2 by 13 and 1 by 7 gives me 20. 7 by 19, I'm not going in decimals to get the exact answer. And so as I got 166 by 35 on the other side. So simply just divided 27 by 91 on the other side. I'm getting y as 2158 by 135 as exact. And in decimals 15.985 or approximately equal to 16. Now when I have y, I can use any of the equation. It was simpler in the second one. There's only x. So just made that subject, took y by 3 on the other side, replaced it with the value of y and got x 2401 by 405 or 5.928. Now I'm using both of these values, fraction of y and fraction of x in the same equations and got this check left hand side equals right hand side. In exam, what you can do is you can also use 15.98 or use 16. You'll get values close to 5 and close to 3 by 5. That is still okay. So for substitution, let's see. So this is 3x by 7 minus 2y by 13 is equals to 5. That's equation 1. Equation 2 is x plus 1 by 3y is equals to 3 by 5, equation 2. So if I have to make any subject, definitely equation 2 is my choice. So from equation 2, I'll say x is equals to 3 by 5 is equals 3 by 5 minus y by 3. So this is my new equation 3. Put equation 3 in equation 1. We rearranged it from equation 2, so we'll substitute in equation 1. I'm copying equation 1 and replacing the value of x as well. 3 by 7, now that's x, is 3 by 5 minus y by 3, x replaced, minus 2y by 13 is equals to 5. Now the only unknown in this equation is y. There'll be only one mistake, which is elementary mistake. 3 times is 9 by 35. 3 cancels out, minus y by 7 minus 2y by 13 is equals to 5. I'm taking all the numbers on right hand side. Meanwhile, if I can take out y as common, this is minus 1 by 7 minus 2 by 13.
How did you get
Is it
y?
y? These two y's.
No, y over 7.
Y over 7. I multiplied this fraction with both of them. So when you multiply it with this second term, 3 cancels out with 3. And we are left with y in numerator and 7 in denominator. Clear?
Yes.
Okay. So y, and there comes in. So this is 1 by 7 and 2 by 13, keeping in mind the negative sign. I'm getting 27 by 91. So that's negative 27 by 91. On the other side, 5 minus 9 by 35. Because we do have calculator in both of the exam components, we can use it freely. So y is equals to, this goes on the other side with the negative sign, 166 by 35 multiplied by 91 by 27. So y is equals to 166 divided by 35 times 91 divided by 27 was 2158 by 135 with the negative sign. So substituting this y in equation 3. Put in equation 3, which is x is equals to 3 by 5 minus y by 3. Now, because that's my choice, I'm keeping them as fraction. So I'll write x is equals to 3 by 5 minus 1 by 3 and take that y inside. Minus 2158 by 135. So 3 by 5 minus minus plus. This is 2158. 135 times 3 is 405. So 3 divided by 5 plus 2158 by 405. And I get 2401 by 405. These are the same answers as we got with the elimination. So having a glance at this, did you figure out where you lacked or made any mistake?
I think it was like at the very beginning, I guess. But
Making the subject or multiplying?
I think making the subjects. Yeah,
Okay.
making the subjects.
So as we would move on through the exercises, you'll see that only the difficulty level will change. No new method, no new concepts. So the most difficult is definitely the fractions, and we go through them slowly. Apart from that, in question 6, you'll see that he will just guide you through words and we will keep on writing the equations and then solving them. Question 6 says, form a pair of simultaneous equations for each situation below and use them to solve the problem. Let the unknown be x and y. So question 6a says, This sum of two numbers is 120. So may I write x plus y is equals to 120?
Yes.
Then it says, and one of the number is three times the other. Find the value of the other number. One of the number, now these are both are unknown. So either we consider x as the larger number or y as the larger number, makes no difference. So I'll say one of the number is three times the other number. So do we agree on these two equations?
Mm-hmm.
Now again, elimination or substitution is a choice. The y is already subject. I can just substitute it. X plus y is equals to 120. 4x is equals to 120. X is equals to 120 by 4. 4 3 times x is 30. So if x is 30, y is equals to 3 into 30, which makes it 90. Now this is done. We can always recheck. X is 30, y is 90. So the first one, 30 plus 90 is 120. And the
Yes.
second one, 90 is equals to 3 into 30, which is 90 equals 90. So yes, that's correct. The question didn't demand to check, but during exam, definitely we'll see that. There are very few topics which we can check on spot to know if we are going in the right direction. B part. The sum of two numbers is minus 34. X plus y is equals to minus 34. Definitely one of these would be negative. And their difference is 5. Again, I don't know which one is positive, which one is negative. So generally we can write like this. Equation 1 and 2. And now we solve them. Hmm. So I'm getting x negative 14.5 and y negative 19.5 and making a quick check. Negative 14.5 minus negative 19.5 is minus 34. And second one is 5. Yes. Try D part. C is similar to AB. Do we have these equations?
Yes. I was trying elimination, but I don't think it's going to work that way.
I just did.
Wait, you did
Do we have
elimination?
the same equations? X plus y equal 34 and x minus y equal 6. The combined age of two people is 34, so we add them.
Yes.
And if one is 6 years younger,
So it has to be
so
X
the
minus.
difference is 6.
Yes.
So you just simply add them and you get rid of y.
Um, yes. And then 2x equals. Okay. Y equals 2x minus- I wrote it differently. I wrote y equals 6 minus x, but okay, I'm gonna try it that way.
No, that is the mistake. Y is equals to 6 minus x.
So I'm
That's the
trying
mistake.
the x minus y equals a 6 way.
Yeah, because x actually could be more than 6.
So we have to subtract
And
the
in this case, x and y cannot be negative because here we're talking about ages.
Mm.
Age cannot be negative. So if one person is younger, whatever the age of the other one is, if one is 100, second one must be 94 for it to be 6 years younger. So that's the difference. So x minus y is 6. Or if you consider y older, we can write y is equals to x plus 6. Compare this statement.
Plus therefore if one
One
person
person is 6 years younger. So there is 6 years older. So
said,
you just add 6 to one of the person and you get the age of the second.
oh, okay.
So we just have to read between the lines, interpret the words, translate these statements written in English to mathematical equations. This is the max difficulty level. For the equations, the fraction form. For the statements, this is it. Number 7. A computer store sold 4 hard drives and 10 pen drives for $200. Now we can use our own symbols. There's no restriction. 4 hard drives and 10 pen for 200. And then the second statement says 6 hard drives and 14 pen for 290. Find the cost of a hard drive and the cost of pen. So we need to find H and P.
Mm-hmm.
I'm going for elimination.
And yeah, me too. Or should I go for the opposite of you?
No, no, you should stick to your choice.
Mm.
I also have that confidence when I'm doing it. I know I'm not preparing for the exam. So somehow I'm mentally satisfied. So one day you'll be appearing for your exams. I've been through them because this is the time when you make the choice and you get your answer correct. That will be helpful in exam as well. So if you choose elimination, do it with elimination, get the right answer. And yes, in your practice time, you can see what happens if you chose substitution.
Okay. 26.
26 for hard drive
Yeah.
and pen drive.
I didn't get wait. I didn't do the pens yet, but
We do have different answers. We'll see. We'll see where is the difference. Just go on.
should I redo it?
Uh, s- Go through that again.
Yeah.
Just don't write it and see where the difference is. Like on your page, rechecking is difficult than redoing it.
Oh. I made like a very bad mistake, but it's like a very easily fixable mistake that I could have avoided. So when I was like timesing the bottom parts by like -2, I times the 14 by 3 instead of -2. So that's
Oh,
why. So I wasn't like really keeping it organized, I guess.
sure. First, I was thinking to multiply with the swap those coefficients, 6 and 4. And then I just realized like that would be 24, 24 each. A large number is not a difference, won't make a difference because we have calculators with us. And then I just realized that half of that is 12. So 3 and 2 could also do the job. So we are getting 25 and 10.
Okay. Shall we do it like with the correct way?
Now we'll spend time on new question.
Okay.
Like we can always polish these questions in our free time. And while we are studying together, we'll explore maximum questions.
Could you also send these questions to me? Or should I take a screenshot of them?
Do take them. I'll also share them without these writings.
Okay.
So, sorry, did you take it?
Um, yeah. Okay.
Number 8. A large sports stadium has 21,000 seats. These seats are organized into blocks of either 400 or 450 seats. There are 3 times as many blocks of 450 seats as there are blocks of 400 seats. How many blocks are there? Okay, you take the lead and guide me through the equations.
Where is was block meter 400 450 feet, 3 times as many. So 3 times as many of the 450. So 3 times the blocks for 400 equals to 450. I've been to 1,000. The seats are organized in the blocks. 400 or 450. So 21,000 divided by 400. and 21,000 divided, yeah, so 21,000 divided by 400 equals to
Why will
x.
we do that? That would mean that there are all blocks divided into 400 seats because 21,000 is a total.
Okay. Uh, there's 3 times as many.
Yeah. So if I just try to interpret the question, I'll say this block is 400 seats and the next block is 450 seats.
Yes.
This is just a copy paste of question, right?
Yes.
Secondly, how many 400 seated blocks are there and how many 450 seated blocks are there? We don't know yet. May I say these are X and these are Y?
Mm-hmm.
So does it make sense? 400 into X plus 450 into Y should be equal to 21,000.
Yes.
All of the X plus all of the Y is equal to total seats. This is equation 1. How do we get equation 2? Second half of the question, there are 3 times as many blocks of 450 seats. So the symbol associated with 450 is Y. So may I say Y is 3 times that of X?
Mm-hmm.
Like if we don't know the total 21,000, I would say there are 3 blocks of 450, then 1 block of 400. Again, 3 blocks of 450, then 1 block of 400.
Okay.
So these are the two equations.
And then we're trying to get the separate blocks.
Now, how many blocks are there? So we just associated X and Y with number of blocks, X blocks of 400 and Y blocks of 450. So we were first going to find X and Y and then answer the remaining part of the question. Now, when we are doing these questions, we just have a sense of acceptability that we know how to solve the simultaneous equation. The extra part is to create that equation, to write that equation.
Twenty-one hundred over 175 equals to x. So that's how many
20,
blocks.
21,000.
Yes, but 2,100 over 175. So just removing the zeros.
Yes, 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 yes.
And then y. Three, 350. It's Can I use a calculator for this one?
Sure,
Oh,
sure.
God, right? So there's 36, 36 450 blocks. And then 400 there is 12.
12.
So
So its
total
total numbers are
48.
8 blocks. Okay. I'll share these questions with answers again. And the next topic is linear inequalities. So basically, we were dealing with linear equations where there were two unknowns, and to solve them, we needed two equations,
Mhm.
and we solved them simultaneously. There were two different basic methods. One is algebraic, the other is graphical. Graphical method, we just draw those two lines and read the point of intersection. Algebraic method, there are two choices simultaneously or substitution or elimination. Now there are linear inequalities. If there is one unknown, we'll need one equation. If there are two, we need two equations. If there will be three unknowns, we'll need three equations in order to solve them. And we just discussed some basics yesterday. X is less than equal to something, X is greater than equal to something, X is less than equal to something, X is greater than equal to something. So when it is less than, the number line moves to left and it is a hollow circle. When it is greater than, the number line moves to right and that's a hollow circle. Again, less than equal to is a filled solid circle. That means the value is included. And this is the fourth one in the same manner. Let's quickly just read through these worked examples. Then we'll practice some. Show the set of values that satisfy each of the following inequalities on a number line. X is greater than 3. Circle is over 3 but is not filled. Greater than 3 goes to right. B part, 4 and 8. Y is more than 4 and Y is less than 8. See the number line. 4 and 8 are not included and the line is there. Then negative 1.4 and 2.8. Firstly, both of these numbers in C part negative 1.4 and 2.8. This should be labeled as well. Let me say this is 2 and this is 3. So 2.8, 2, 1, 0, 1, -1 and -2. So from the question, we can see that 1.4 is not included. That's a hollow circle. And 2.8 is included. So that's a solid circle. Okay. So draw the number line to represent the possible values of the variable in each cases. So let's quickly make some choices and we'll compare our number lines. Less than, greater than, less than equal to, greater than. I think the last three would fulfill all the requirements. So let's start with G part. 14.3, question 1, part G. You go first and then we'll compare.
Okay.
G part done?
Yes.
Okay, just coming there.
Should I move on to
Okay,
8?
so this is 1.2 and 3.5 and both of them are not included.
Yes.
H and I.
So The one, yeah, I'm done with that one too.
So minus 3.2. This is positive 2.9. Hollow circle, solid circle, and this line. And the last one, 3.1, 4.5, and both are included. So both are solid or filled, and this is the line. Now, before we jump on to question number two, in two, the examiner is not asking us to draw the number line. Sometimes it is easy to understand when we can actually visualize. So I'm doing the same thing on question one. It says write down all the integers that satisfy the inequality. If I just come back to this, integers are whole numbers. So this G part, this is more than 1.2, more than 1.2. The first integer is 2. Then the next one is 3. And I
Mm,
cannot go beyond that. H part, more than 3.2 is
four.
minus 3
Oh yeah.
is 2. Even if you select one, your answer is correct. But make sure you don't miss any. Minus 3, minus 2, minus 1, 0, 1, 2. Can I write 3?
No, because it's two
No,
point
that's 2.9, right? So minus 4.5, what would be the least one?
um 4.
That's right, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, and I'll slow down. This is 3, and can I write 4? No. Now in question number 2, we're not drawing any number line, and you're just answering them. So let's start with B part. This is 7 is less than H is less than equal to 19. So
8,
write down our integers. 8,
8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
okay. So these are the values. If I just look at question number A, 2A, I left that deliberately to discuss this thing. It says 3 is less than B is less than 33. When the question says write down all the integers, it's better to display all of them. Other than that, you remember we've read sets.
Mm-hmm.
So if I just write it like this, and I know the first choice is 4 because 3 is not included. 4, 5, 6, 7, 8. This pretty much explains the complete sequence. Like for the examiner, I'm not leaving any ambiguity.
So this is
Examiner would know. Yeah,
okay.
this is it. So we can write it as sets. Now these brackets and commas are explaining the examiner what I'm doing. If I'm making this, if I'm not writing it like this shows that I'm displaying that set of values. So 4, 5, 6, 7, 8, and so on. I've explained the sequence that these are all the integers without any gap up to 32.
Mm-hmm.
Or else we'll write it like these, just the numbers and all of them. Try E part. Minus 3 greater than equal to F is less than equal to 0.
-3, -2, -1, and then 0.
Very good. Minus 3, minus 2, minus 1, and 0. The examiner is just playing with these signs, twisting the signs. Okay. 1 with the decimals. F part is 2.5 less than M is less than 11.3.
Mm, it's 3, 4, 5, 6, 7, 8, 9, 10, 11.
11. Okay. H part. Pi is less than R and R is less than 2 pi.
4,
You know the value of pi.
yeah,
Very good.
yeah,
Four.
4, 5, and then 6.
then 6, right? I. And this is square root 5 less than W is less than square root 18.
Mm. 3.
3.
4. And then
I also want to be sure what square root 18 is. So this is 4 point something. So yes, 3 and 4. Solving inequalities algebraically. So we'll just consider the sign as if it is a sign of inequality and simplify the questions with one condition. Let me show you. For example, the question is 2x plus 10 is less than 30. Example question. So 2x is less than 30 minus 10. 2x is less than 20. X is less than 20 by 2. And x is less than 10. On the other hand, when I say that consider it as a sign of equality, it's just like this. So 2x is equal to 30 minus 10. 2x is equals to 20. X is equals to 20 by 2 and x is equals to 10. So there's no difference in these steps. All the Demas rule. And even if this was equality, it makes no difference, but
so
only one. Go ahead.
so they're both the same?
They're both the same with the difference when we actually divide with the negative sign. For example, the question was 10 minus 2x is less than 50.
Mm-hmm.
And on the other side, this is 10 minus 2x is equals to 50. So I'm going to solve the right hand side first. Minus 2x is equal to 50 minus 10. Minus 2x is equals to 40. X is equals to 40 by minus 2. And x is equals to minus 20. Now coming to the inequality. Minus 2x is less than 50 minus 10. Minus 2x is less than 40. Now I'm slowing down. What am I going to do? Divide with the negative number. Whenever we divide or multiply with the negative number, through the sign of inequality, we reverse it. So x 40 by negative 2, I'm dividing with negative numbers, I'm changing that sign. This becomes x is greater than minus 20. I'll explain. I just divided. Let me multiply and then I'll explain. Same question. 10 minus 2x is less than 50. Minus 2x is less than 50 minus 10. Minus 2x is less than 40. Now I'm going to multiply. I'm multiplying with the negative on both sides. So this becomes positive 2, that becomes minus 40 and the sign changes. Now I'm dividing with positive 2, so there's no need to change the sign again. So x is greater than minus 20. Let's compare these two. Do we have the same answers?
Yes.
And now explaining the logic. 10 minus 2x is less than 50. I'm bringing the numbers to left hand side. 10 minus 50 is less than 2x. No division, no multiplication, just moving across the sign. So minus 40 is less than 2x. Now dividing with positive number means no change in sign. Minus 40 by 2 is less than x. Minus 20 is less than x. Are these same?
Yes.
So x is greater than minus 20 in both of the cases. So just remember, whenever we divide or multiply with the negative sign through the inequality, it changes. Now, one of the student asked the question, why are we not changing this sign? So for his sake of understanding and satisfaction, I said, you can do that. This is pointing towards right. You change it, and now this is pointing towards left.
Why would they ask that? It's
He
because
just did
it's a completely different thing. It's not really
completely.
okay.
So the point is, keep in mind, whatever the case is, we always reverse the sign.
Mhm.
Even if this is less than or greater than or less than equal to or greater than equal to or even equal to, just reverse it. Now let's go through the questions. If there is no division or multiplication, we'll just simplify it. So the first one says find the set of values of x for which each of the following inequalities hold. Number one, 3x minus 4 is less than 14. Solved example. Making x the subject, took 4 on the other side, that's 18. Divided by 3 on both sides is x is less than 6. Now, if this question would have been that list all the values, or let's say all the positive values, we'll say 0, 1, 2, 3, 4, 5,
Yes.
and so on. Now, all of these are actually single inequality. No two inequalities. Whenever we'll have two of these, we will write only those values which actually satisfy both of them. For example, let's say the question is 3x plus 4 greater than 13. 1. And the second inequality is 2x minus 5 is less than 17. So I'm going to solve the first one. 3x is greater than 13 minus 4. 3x is greater than 9. X is greater than 3. And on the other side, this is 2x less than 17 plus 5. 2x is less than 22. And x is less than 11. Now, whenever we have both of these in one question, we will only write those values which satisfy both of these answers. So I'll say, therefore, x is equals to 4, 5, 6, 7, 8, 9, 10. Whereas if I look at the first inequality, this would say that 100 is also the value. Do you agree?
Mm-hmm. It
But the second one contradicts.
doesn't
So
matter.
we are writing only these values. Now, visualizing definitely helps. This was 3. This was 11. The one on the left says that it is more than 3 all the way right. One on the right says it is all the way to left of 11. But both of them, they agree on this part. So we have 3 and we have 11 and it is between them. So single inequality or double inequality, and whenever we divide with positive or negative sign. Solve each of the following inequalities. Some of the answers will involve fractions. Leave your answers at fractions in the simplest form where appropriate. Just as in C part, it says 15y is less than equal to 14. So y is less than equal to 14 by 15 and we'll leave it as it is. It cannot be further simplified. So try question number D. Very simple. Without writing, you can answer that.
Negative 14 over 7. Y is more than negative 14 over 7.
And that would be y is more than -2.
Yes.
Okay, so let me just have a look. This is just these are
I want
simple questions.
it says simplify as much as possible. So could we still write -2, or do we have to write -2 over 1?
-2.
Okay.
Yeah, no need to write the denominator as 1. Okay. So, so let's just randomly go through some questions. Answer the first two like without writing. These are simple.
A and B
Yeah,
is just 2. A is 2. So
that's right.
X is smaller than 2. And then B is X is greater than 3.
3. G part, garden.
X is smaller than 6.
Right. F part,
X is smaller than 5.
5,
5? Or,
4,
oh no, 4. I think
4.
yeah, I didn't change the sign for the plus one.
No issues, no issues. And E part,
E is, so X, yeah, C is greater or, I mean, yeah, greater or the same as 2.
sorry about the interruption.
2.
So E part is 16. Yeah, C is greater than 2. I part,
And X is greater than -15.
very good. J part,
G is greater or the same as 4.
very good. K part, if you wish to write, you can do that.
Yes, not 80. 176 over 22. That is 8.
That's
Yes.
right. So there were two choices in this case. Either you multiply with the bracket or you just take 22 on the other side, which was a perfect factor. So this is lesser number of steps. W is less than 4 plus 4 and W less than 8. Or we could just write 22 W and 4 to the 8 is less than 88 and so on. L part 11.
0.7.
That's right. So do remember this in exam. Whenever you do, answer as fractions.
7/10.
7/10. Okay. So in question 2, we might need to write them. Let's try B part. 10q minus 12 is less than 48 plus 5q.
Both? I mean, yeah, Q is smaller than 12.
Q is less than 12, yes. F part, feather.
Negative 0.25 is smaller than, yeah.
I'm getting -1. Did you just multiply 1 by 2 with the fraction?
Sorry?
Did you multiply 1 by 2 with the fraction?
Normally I did it when I was moving the brackets to the other side, but then I did it with, yeah. So I did do it with like multiplying the 1/2 with the brackets. But, so 1, because 2 over x plus 5 times 2. So yeah, 1 is less than. Did you get a -1?
-1, yes. In the first one, I just took that 2 on the other side, make it 4. And then this was +5. So when it goes on the other side, that becomes negative. 4 minus 5 is -1. And if you open the brackets, this is 1 by 2x plus 5 by 2. Then take the numbers on one side. 2 minus 2.5 is negative 0.5. Then you multiply it with 2 is -1.
Okay.
H part. So basically, these are not hard questions. So we just simplify them slowly, avoiding any careless mistake. And copying the correct values are part of it.
(44/3). Y is smaller than or equal to 44/3.
That was quick. 2y minus 14 plus 6 is less than equal to 5y. 5 3 times 15, 21. So 5, this is 3y. 15 plus 21 is 36. So minus 36 minus 14 plus 6. 6 minus 36 minus 14 is minus 44 less than equal to 3y. So minus 44 by 3 is less than equal to y. Is it?
I got 44 over 3. I don't think I got, no, I didn't get negative. I got 44 over 3 because I didn't move it to the other side. That's why. I
That
didn't,
shouldn't make any sense.
yeah.
Then
So
in that case, you should have like negative y on one side.
I had y on the other, I had 3y on the other side. And
On left hand side or right?
uh I'm sorry, I'm trying to find I had it on the yeah, I had it on the left.
So that should be negative 3 because there was 2 already. And when you take that 5 on the other side, that becomes minus 5. You see these two?
Mm-hmm.
2y and 5y. So when you take it on the left hand side, that becomes minus 3y.
Mm-hmm. Oh, when I did it, oh, I see.
And then do not forget to reverse the sign. So I'm copying this statement again. 2y minus 14 plus 6 is less than equal to 5y plus 15 plus 21. So now I'm taking letters on left hand side. 2y minus 5y and all the numbers on right hand side 15, 21 and changing signs 14 and minus 6. Now this is negative 3y is less than equal to 15 plus 21 plus 14 minus 6 gives me positive 44. And then when I divide with the negative number, I change this sign. So y is greater than negative 44 by 3.
Okay.
So far, simultaneous equations and inequalities, either the question would say mention all the integers or just simplify as a number line. So I'll share both of these exercises and you can practice the questions we skipped along with the answers.
Okay.
14.4 simultaneous equations and statement questions. Anything you would like to ask?
No.
And before the next class, I want you to be very confident because one step ahead, we'll be moving one step ahead when we solve these. We'll have that understanding that we understand the inequalities, and this would be shading.
Okay.
Like when we are talking about the shading, we'll only do it when we are clear about these inequalities and number lines.
I'll do the rest of the questions that you sent me from like yesterday. And then also I only had a question on can you scroll down a bit more? And yeah, on 3C.
3C.
On
Okay.
3E, sorry. I saw it wrong.
Okay. It says solve each of the following inequalities. Some of the answers will involve fractions. Leave your answers as fractions in the simplest form where appropriate. Okay. So let's see what it is. It says 3 by 8 into 2D minus 1 by 3 minus 2 by 9 bracket 7 minus 3D bracket close greater than equal to 1 by 4d plus 2 in numerator d minus 8 by 7. Okay. Now there are two ways I can take LCM of 8, 9, 4, and 7 and then simplify, or I can just first multiply these fractions inside. That's up to you. So I'm multiplying them. 3 2 times is 6d by 8 minus 1 by 8. 7 2 times is 14 by 9 minus minus plus, and 3 1 times 3 2 by 3 d greater than equal to d by 4 plus 2d by 7 minus 16 by 7. I'm taking all the variables on one side and all the numbers on one side. So 6 by 8d and then 2 by 3d, then bringing this minus d by 4 minus 2 by 7d is greater than equal to now all the numbers on the other side. So 1 by 8 goes there, sign changes. 14 by 9 goes there, sign changes. And negative 16 by 7. Now I'm adding these. 6 divided by 8 plus 2 divided by 3 minus 1 divided by 4 minus 2 divided by 7. 37 by 42. 37 by 42d. On the other side, 1 divided by 8 plus 14 by 9 minus 16 by 7. 1 by 8, 14 by 9, 16 by 7 is 305 by 504. 305 by 504. Now cross multiply. So D is greater than equal to minus 305 by 504 into 42 by 37. 305 by 504 times 42 divided by 37 gives me 305 by 444. So leaving the answer in fraction form.
I think when I was doing it, because my answer didn't match, because there's so many steps to it, I think I messed up on one of like the negative signs when I was doing it. So
Question was easy, just elementary steps are a little longer. Anything else in this worksheet?
no.
Okay. Okay. Now we've done equations, we've done inequalities, and now these are shading using the inequalities. So let's discuss some basic things first, and then we'll come to this exercise. So if I write some inequalities and I ask you which side it lies on, let's say this is x-axis, this is y-axis, and I draw a line which says x is equals to 2. And there are these regions, A side and B side. So if I say x is greater than equal to 2, which side will you shade?
I would shade that side B.
B, that's right. Now I'm drawing a dotted line which says x is equals to 3. Dotted line actually means the line is not included. And it says x is less than 3. So C or D?
So it'd be C.
That would be C. And it is clear that it is all the way to the left. There's no limit. So same way we go with Y. And we have a line. This is Y is equals to 7. And it says Y is greater than equal to 7. So E and F, which side?
We would do E.
E. X-axis, Y-axis, and it says Y is less than -3. So a line at Y equals -3, G and H, which side?
It would be H.
It will be H. That's right. So we've done X both greater and lesser, Y both greater and lesser, and we've seen the difference between greater than equal to and only greater than. Equal to means a solid line, and only greater or lesser means a dotted line. The line itself is not included. Now we are going to include X and Y both in the lines. And when we include them, X and Y both, we know that they are now not vertical and not horizontal.
Sorry.
For example,
To repeat because it was like kind of glitching.
yeah, when we have X and Y both, this will not be vertical. This will not be horizontal.
Be
For
diagonal.
example, this is the line diagonal, yes. So Y is equals to X plus 2. Let's say this is the line. So this is X-axis. This is Y-axis. Now there are again two sides. One is A, one is B, and this is the equation of that line. So if I write Y is greater than equal to X plus 2, so A or B?
It's going to be A. A?
That is correct. I tried to confuse you by writing the letter B physically above A, but your approach is correct. When we are looking at both of these X and Y, we always prefer Y. We ignore X. So sometimes what the examiner would do, he'll write both of them on one side. For example, it says Y minus 2X is greater than equal to 3. And the line looks like this. And we have sides E and F. So what would be shade? When we have both of them, you can always ignore X.
The other side. Let's do X. So it would be E still.
Yes, it is E. Because if I just ignore that, so this side becomes that side which is actually above and F side is below. If at any stage you get confused, consider them as stairs. So you'll always know which side is upper side and which side is the lower side.
It's still the same for like negative ones.
Yeah, let's do it. For example, we have this line and the equation is y is equals to minus 2x plus 7. And this is side A. Let's say this is side B, and it says y is lesser than and equal to minus 2x plus 7.
So A would be.
This is
Oh,
B
B, because it's less.
because it's less. So it's now below the line. So we can always consider them as stairs. So this is the upper side and B is the lower side. So we are actually ignoring X at all times. When there is X and Y both, we can ignore X to find the region. Now a little trick question. If I say x minus y is equals to 7, and this is the line, and there are again two regions, upper side and lower side, and I say x minus y is greater than 7. So what will we shade? B or D?
We're going to shade B.
We are not going to shade B. We are going to shade D. Trick question. Where is the trick? This is not y. This is minus y. So we always rearrange for ourselves and we see that this is x minus 7 greater than equal to y. I'm actually interested in positive y, even if I arrange the remaining equation or not. See this
Oh,
new
so
equation.
yeah,
Do you agree that this is now D?
yeah, because it's less
And
than.
another arrangement. X greater than equal to 7 plus y. Do you still agree that this is D?
Yeah.
Because we can ignore x. Another arrangement. Keeping 7 there, bringing x on this side, B
Yes,
and D.
it's D.
Another arrangement. 0 greater than equal to 7 minus x plus y. We can actually ignore everything and we are just looking at y.
So it's still
But
yes.
what it needs to be positive y. So we'll look at positive y and then we'll see it is lesser than or it is greater than. Okay.
Yes.
Now let's go through the exercise. And definitely we will have more than one line on one graph. So now this is very easy for you. Yellow side is y greater than 3 and pink side is less than 3. Now Q and P. Obviously, if we are talking about Q, this is y equal to 2x plus 1 because it lies exactly on the line. And if we are talking about point P, that is greater than y. If I have to favor this region, I'll be writing y is greater than 2x plus 1. In case of Q, this is equal. Below this, it would be y is less than 2x plus 1. Region yellow and pink. Yellow is greater than, pink is less than. It lies below the stairs and yellow is above the stairs. I'm not going in this detail. We've already covered that topic. Y equals mx plus c. We know m is the gradient. C is the y-intercept. Whereas this is positive or negative?
And it's a positive,
It's
positive
a positive. Very good. And y-intercept is positive or negative?
y-intercept is also positive.
It's also positive. So we're not going in that detail. We already know that. Now when I'm looking at this, be careful. This is again a trick question. This is not positive y. So for myself, to be sure, I will always rearrange. And I'm rearranging this as well. Now I am pretty sure. I don't want to puzzle my mind. I don't want to solve it mentally in air. I want to write it down on the piece of paper to make it easy for me. I don't want to risk my marks. So when it's written, now I can clearly see that y is greater than. And greater than side is above the line, which is yellow. Yes. Below, pink. Yes. So we are always comparing the equality sign, inequality sign with positive y.
Y is greater than,
Yeah.
but isn't the positive y on the less than side? Or
What are you talking about? Yellow or pink?
pink.
Pink, okay. In that case, it is less than.
Mm-hmm.
You see, lesser side is basically the pointed side.
Oh, so for basically when we're doing more than, we have to put the negative y if it's not negative on the more than side.
We will never compare negative y. We will always rearrange.
I mean for the yellow.
For the yellow, 2x minus 3y is less than 6. That was the original equation. So we rearranged for ourselves and took 3y on the other side, made it positive 3y.
Mm-hmm.
Now I'm comparing it with the sign. Now see 3y is on the greater side. You
Mm-hmm.
see this sign
So
of
positive.
inequality. This is the lesser side, this is the greater side. So
Oh,
3y is actually greater.
I saw the 3y as a negative when I saw it. But okay.
So, confusion clear?
Yes.
Now we have this equation. If we have to write the sign of inequality, this is the equation 3x minus 5y is equals to 15. I am not sure till I see positive y. I will not write that sign. I will not do the math in here. I will write it on a piece of paper. So I'm rearranging it. 3x is equals to 15 plus 5y. Now, if I'm talking about the pink region, what sign should I add? Choose A or B.
Mm, you should do A.
Okay, if this is the line, is this region above or below?
It's below.
It's below. If it is below, it should be less than.
Mm-hmm.
Y should be less than. So why A? I should select B. 3x and y is on lesser side. This is y and this pointed side is the lesser side.
Oh, wait. I thought we were doing like the A as the Y. Because I saw A as less than. That's why.
Yeah, that is the sign. Yes, that's true. But you see where your y is on the equation. Region is y and region is below. So region is lesser, so y should be lesser.
Okay. Because I saw it like the option A as like the less than sign.
I
But
got your point. You had in mind that this is the less than region and this is the less than sign.
but
But
it's
we
supposed to be
need to
B
know
for the equation.
what is written on left side and what is written on y side. So in my first choice, I know that x is lesser. In my second choice, I know y is lesser.
Mm-hmm. So that's why. It depends on
Oh,
the equation. So yeah.
yes. On the contrary, y was actually written on the right hand side, so I had to consider b because region is for sure lesser. So when I'll put in b, then y will be lesser. So now I can write 3x minus 5y and this sign. Again, that's a minus. So 3x minus 2y is equals to 0. I'll rearrange. This is 3x is equals to 2y. Now the region is greater or lesser.
Pink region?
This, yeah, pink region is greater or lesser.
Pink region is greater.
That is greater. So y should be greater or lesser.
Y should be greater.
Y should be greater. So 3x and y. Adjusted.
Yes.
Now I can rearrange this to get the original equation 3x minus 2y and I got my sign. So 3x minus 2y is less than equal to 0. Adjusted. Now see in this question, the equation is not given. This is worked example. Let me hide the solution. It says find the inequality that represents the unshaded region in this diagram. Okay, I didn't focus on that unwanted region shown. Shading the unwanted. Okay. I actually didn't read this statement. Let me come here to make it clear. The question will sometimes tell you that our required region is shaded, and sometimes it will tell you that the required region is not shaded. So write the inequality for shaded region. Okay. Question is there. Write the inequality for shaded region. X-axis, this is y-axis. Now we see this line. This is x is equals to 2. And I'm shading this side. Question says write inequality for shaded region. So what would you write?
X. X is greater than 2.
X is greater than and
2.
equal to 2 because it's a solid line. And when it says write the inequality for unshaded region, I'm drawing a new equation, region, and this is y is equals to 7. Read the wordings carefully and then answer.
Y is less than 7.
Y is less than 7. So this was the difference. Actually, the concept is still same. I didn't read the statement and I was following the shaded region. The question was actually asking about the unshaded. So what we'll do, we'll just reverse the sign. So I'm solving for this question. Find the inequality that represented by the unshaded region. So I am interested in this white region. Now, first of all, I need to know the equation. So equation is y equals mx plus c. I need to know the gradient. Can you help me with the gradient?
Gradient is 4.
That is y-intercept.
Or, so the
Y is
gradient
equal to mx plus 4.
is 2.
Gradient is 2. Rise over run. So gradient is 2. Y is equals to 2x plus 4. Now I know the equation. When I'm interested in the white region, equation to inequality, what should I write? Now this y region is below the line or above the line?
It's above the line.
It's above the line. So y should be
Greater.
greater. So y is greater than 2x plus 4. So as we'll move on, first the equations were given, we just had to put the sign. Now the equation is also missing. For questions 1 to 3, show your answers on grid with x and y axis from -3 to 4 by shading the unwanted region. Show the region represented by this. Now what's happening? He's giving the equations and regions. We have to draw the line and then shade the region. I'm quickly making these sketches. Question 1, 2, 3, same demand. And the requirement is by shading the unwanted region. Shade the unwanted region. And let me copy these equations for once. Number 1 is 2y minus 3x greater than equal to 6. Second is x plus 2y is less than 4. And third is x minus y is greater than 0. Now these are inequalities. I'm drawing them, considering them as equations. So number one, this is 2y minus 3x is greater than equal to 6. Now, if I just consider that x is 0, is
Mm.
y 3 when x is 0? X 0, y 3, do you agree?
When x is 0, -3 would be also 0. And then y would be 3. Is
Y
that?
would be 3. Like y is actually greater than equal to 3, but what I'm doing, I just need to draw the line. So I'm considering this equation.
Mm-hmm.
So when at x 0, y is 3. So let's say this is 1, 2, and 3. 0, comma 3. The question requires a little more working because it says draw it from -3 to 4. In that case, what are we doing? We are plugging in x minus 3, then -2, then -1, then 0, then 1, 2, 3, 4. We are working on these 8 values. I'm just quickly going through the sketch. And when y is 0, I can see that x is -2.
Yes.
So whatever we do, we solve this with like 8 points or 800 points. It will still pass through these two. Now, this is a rough page. We both know that. On
Yes.
a graph page, we'll have a proper grid, and definitely still it is going to pass through these 2 points. Now, having said that, the line is in front of us, the equation is in front of us, the inequality is there, and the question says shade the unwanted region. Now, it varies from person to person. For me, it is always helpful when y is positive, and it is already positive. I don't have to make any changes. I see that y is positive and y is greater than, I know this is the region. But what do I have to shade?
The unwanted. So
Unwanted region. So here I go. The requirement of the question is fulfilled. Equation was given, we drew the line, and we did the shading. Second question. X plus 2y less than 4. I'm doing it in all complete manner. What the requirement of question is from -3 to 4. So I would say x -3, -2, -1, 0, 1, 2, 3, 4. And for y, I can rearrange for myself, which is y is equals to 4 minus x by 2. I'm using this. So 4 minus -3 by 2. So at -3, this gives me 3.5. And at -2, it is giving me 3. At -1, this is 2.5. At 0, this is 2. So it is actually also giving me a trend, and I know it is a straight line. So there's a change of 0.5, it reducing by 0.5, 1.5, 1, 0.5, and 0. So now I know all these points and I can plot them.
well, it's at 0, 4, obviously, since
Yeah.
it went.
So what the examiner is expecting, this is 1, 2, 3, 4, 5, and so on. -1, -2, -3. So at -3, we have 3.5. 1, 2, 3, 3.5. -2, it is 3. -1 is 2.5. 0 is 2. 1 is 1.5. 2 is 1. 3 is 0.5. 4 is 0. So we have these points and we draw the line -3 to 4. And this was 1, 2, 3, 4, -1, -2, x-axis, y-axis, and shade the unwanted region. So this was my equation.
Y is positive, so we shade the less than.
You're right. Y is positive and it is less than.
So we
It
would
means it is below. This is the correct region, but what do we have to shade?
be unwanted. So the above, so the more
So we
than.
slowly do it. We will never rush through these questions. This is the unwanted region. So like we did everything and we shaded the correct region, and the question was interested in unshaded, was interested in unwanted region. So we have to read the question carefully and fulfill the requirement of the question. Last equation is x minus y greater than 0. I'll quickly draw that. X minus y is greater than equal to 0. I know that this will pass through this point. So if I just rearrange, it's greater than equal to. Now I see this is below this line. I just rearranged for myself and I understood that this is below the line. So unwanted is above the line. Finished. This was x-axis, this is y-axis, 1, comma 1, 2, comma 2, 3, comma 3, 4, comma 4, -1, -1, -2, -2, and so on. Clear?
Yes.
Whenever we write it on piece of paper, we are not pressurizing our mind. Number 4, shade the region that represents each inequality. So that is in the same way, question 1. Now he's actually missing more of the data. So number of marks for that particular question will increase. Now, how is less data given in question 4? In question 1, equation was there. In question 4, equation is there. But there was a guide through that we have to draw from -3 to 4. Now, there's no guide, so we can draw as we wish. Definitely, we always prefer that it should pass through y-axis. So we always, what we do, once we take x0, once we take y0. Now, 4a, look at 4a. What happens when you take x equal to 0?
It passes straight through 0.
X is 0, but there's y. When x is 0, what is y?
Mm. It will equal to 3.
Equals to 3. So when x is 0, y is 3, I'm drawing this point 0, comma 3. Now when y is 0, what is x?
Then x is -3. No, x is -1.
Again,
X is 1.
positive 1. So we know y 0 and x 1. So is this the point?
Yes. If that is 1, then
So now I know these 2 points and I know the intersections of these two x's. So I'm not interested in like drawing it from -5 to 10. These 2 points, because it is a straight line, they are more than enough to answer any type of question as far as it is a straight line. So it passes through these 2 points. Now by shade the region, in question 1, it was unwanted. In question 4, this is the region. So go through the statement very carefully.
y is
Equation is drawn. Y is, yeah, sure, go on.
y is greater than, so it would be above the staircase, so more than.
Above. So more than yes. So we're talking about this side. Now these are just number of questions. Nothing new in question 4. Mm. Now question 6. See, Question 6 is reverse of 4. Equation was given. We did the equation. We did the line and shading. Now line and shading is given. We need to write the inequality. For each of the following diagrams, find the inequality that represents the unshaded region. So we are interested in the white part, unshaded region. First of all, I need to write the equation. I can see the intercept is positive and gradient is positive. May I write y is equals to, now this is rise over run. Gradient is 4x plus 5. Do you agree? Equation.
Which parts did you do rise over run with?
Rise over run. See for yourself. Take any two good points. I'll highlight one.
Oh, yeah.
We are not confused with this point. I know this is x minus 2 and y minus 3. But if I took this point, I'll be confused.
So you
So
did
take good
negative
points.
3 and 5?
Take any. You take any. And see
And
what
then,
is rise and what. I just marked one point. You can select any two.
yeah, 8. So 8 divided by 2, so 4.
Yeah. And if you can break these in these 2 points, this is 4 over 1. So rise by run is 4, gradient is 4, and y-intercept is clearly 5. Intersects the y-axis at 5. So equation is 4x plus 5, and we are interested in the unshaded region. Unshaded is above or below?
Unshaded is below. I mean, above.
Unshaded.
Yeah,
Yeah.
unshaded is above.
So it is above. So y is greater than, and because it is a solid line, greater than equal to 4x plus 5. First part done. Now during exam, this is a limited edition. We need to show some working, at least for the gradient.
So we have to like draw the lines for
I'll,
right.
I'll show you. I'll show you. I'll write this. Y is equals to 4 by 1 gradient, and then I'll write y is equals to mx plus c. So y is equals to 4x plus 5. This is it. This is complete and more than enough.
Okay.
For B, I'll do it from scratch again. What we need to show in exam. Because I need the equation, I know that I'll be starting with y equals mx plus c, but why should I write that when I know that I'll be finding the gradient first? So gradient is rise over run. I see a good point, I see another good point. So this is 1 by 1 and obviously negative. So gradient is minus 1. So y equals mx plus c. Y is equals to minus x and y-intercept is 3. Now the unshaded part, is it above the staircase or below the staircase?
Below.
It is below. So y is greater or lesser?
Less than.
So y is less than. So y is less than minus x plus 3. And note that there's no sign of equality because it is a dotted line.
So just without the
Yeah.
same.
Compare question 1 and 2, A and B. That was greater than equal to because it was a solid line.
And
Now
because
there's
it's
no sign of inequality because it is a dotted line. Now C part is yours. Do this completely and give me the inequality which satisfies the unshaded region.
y is greater than or equal to 1 over 3x plus 1.
Please say that again.
So y is greater than or equal to 1 over 3x plus 1.
Let me have a look. Rise over run, correct. One correct. Unshaded region is this. Greater, very good. It's complete and correct. D part. And someone could also write this 3y is greater than x plus 3.
Yeah.
Both are same.
Y is less than or equal to 3 over 2x.
Y is less than equal to
3 over 2.
by 2x. Okay, rise, overrun. There's one mistake.
Is it negative?
Yes, that is negative. Now it's correct.
So we can
So we
also
write the
2y 2y is less than or equal to 3x. Negative 3x.
yes. Now, what can we expect from this topic to go on? He'll be writing more than one equation on one graph,
So more than one line.
more than one line, like this. So y is equals to 4. As we go, just see if you can find those lines. Y is equals to 4. Then y is equals to x plus 2 and x is equals to 3. So 3 lines. Now what does the question say? It says by shading the unwanted regions, show that the region defined by the set of these inequalities unwanted. If we are shading unwanted, this is the white region which actually satisfies all the three. If I just choose any point out of this, let's say I choose this, which is x2 and y1. And if I plug this in the first inequality or in the second or in the third, it will be correct. For example, if I put this in the first one, where x is 2 and y is 1, so y is 1 is less than 2 plus 2, 1 is less than 4. Is it true?
Yes, for the equation.
In the second one now, y is 1. So I put in y less 1 less than 4. Is it true?
Yes, since it's the unwanted.
Last, yeah, last one. 2 comma 1, x is 2. So if I just put x2, this is 2 less than equal to 3. Is it true? Yeah, 2 is less than 3.
3 for x equals to 3. But yeah, 2 is less than 3.
Yeah. So this is again true because I selected the point from the region which was satisfied by all three inequalities. Now let's choose another region. If I choose this point, this is x5 and y2. Now let's check. y2, x5, 2 is less than 5 plus 7. First one is true, yes. Now let's check the second one. It says 5 comma 2, y is 2 is less than equal to 4, yes. Let's check the third one. This is 5 is less than equal to 3, no.
5 is not less than 3, so
Yeah. So this is the region which actually satisfy all three inequalities. And even these signs of lesser than and lesser than equal to, considering the dotted and solid line. So this is a solved example. Let's quickly go through this. This was y is less than x plus 2. I know this is the line, dotted line. And being less than means it is below the staircase and we have to leave unshaded. So I'm shading or cancelling out the upper part. Then the second equation is y is equal to 4. This is the straight line. It is less than. Less than is the region, so I discard the upper part. And then again, x is equal to 3. X is less than 3 is the region, so we discard the upper part. And whatever is left is the correct shaded region.
That satisfies all the equations.
That satisfies all the equations. Now this says by shading the unwanted region, show the region defined by the set of inequalities, this, and this. Okay. So let's copy the equations first. X plus 2y is greater than equal to 6. Second is y is less than equal to x, and x is less than 4. Now it has to be accurate. It has to be plotting. I'm just sketching it quickly because this all needs to be done on graph paper. Now, when I look at the first one, again, let's have some imaginary marking 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And on the other side, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when x is 0 in the first one, when x is 0, y is 3. And when y is 0, x is 6. So I'm getting these 2 points. And we draw a line through it. I'll try to keep same colors to avoid any mixing. Second one in blue, y is equals to x. x1, y1, x2, y2, x3, y3. So this is it. We'll come to shading once the lines are done. And the last one in black, x is less than equal to 4. So I'm drawing a line at x is equal to 4. So now let's do this third one first. It says less than 4. So the actual region is to left of it. And the requirement was
Unwanted.
by shading the unwanted.
So more
So
than.
unwanted is on right hand side. So shading the unwanted. So let's say this is discarded. Now the blue one, y is less than equal to x.
So y is less than, so we do more than. So above.
Yes. So we shade this side. So this is discarded. Now the one in green.
Y is more than, so we do the less than, so below.
So below the line. So my required region is this. In some of the questions, it will tell you to label the region as R. Now, what will happen in exam if some of the student performs entirely opposite of it? For example, he is doing this 1, 2, and 3, and he's doing this.
Then it's going to be wrong.
Entire opposite. So if this question is 3 marks, the first one would get 3 by 3, and he will get 2 by 3.
Because everything else is correct.
In fact, all 3 inequalities are wrong because he didn't identify one as correct. Because it needs to be above, it needs to be left, it needs to be right, and so on, like you did. But the examiner says he identified the correct equation. He just got confused between lesser and greater, but he identifies the correct equation. He drew the correct line. So this is the topic. Whatever you do, provided you've done something the least one would score is 50% marks. So let me have a quick look. I think there's nothing more than, yeah, now just the practice is left. Question number 2. Can you quickly try that and somehow show me?
Okay.
Let's just try it and then I'll quickly sketch it.
Okay. Um, I'm gonna try and show it.
Okay.
Wait, I should label it with R, right? The required. I don't know if you can see.
Show the region defined unwanted. Yeah, I can see. I'll quickly just sketch it and we'll just match our answers. By shading the unwanted region, show the region defined with the inequalities. Okay. So y intercept is 5 and gradient is negative. So this passes through 5 and 5. This is x plus y greater than equal to 5. The other one is y is less than equal to 2. It passes through 2. Y is less than equal to 2. The third one is y is greater than equal to 0. So this is y is equals to 0 and greater than equal to is above this. So I'm discarding the region below it. Y is less than 2. So I'm discarding the region above it. And greater than 5. So I'm discarding the region which is below this. So this is my region. Do we have the same answer?
No.
Can you just show me again if we can figure out where the problem is? Okay. I think y is equal to 0 is correct, 2 is correct, but the one with x plus y, you took the positive gradient. But what about the y-intercept 5
Wait, so I took the positive gradient?
and y-intercept? I think you've passed it through the origin.
Yeah. It was no, it's below the origin actually. It's not even above it like it's supposed to be. So, because both of them are 1.
Now, while I was drawing this, x plus y is greater than equal to 5, I was thinking this.
Mm-hmm.
So I can match it with y equals mx plus c. So m is negative and then c is 5. So I knew gradient was -1 and y-intercept is 5. And another way, when you imagine x 0, you get y 5. When you imagine y 0, you get x 5. So that is what I did, 5 5 and negative gradient.
Yeah. So I did 5 0 and -5. No, 0 -5. So
That was the mistake.
yeah,
This is positive 5.
the correct region is over there. Okay. That's a similar question, right?
Yeah, I'm just looking at it, why I split it in A and B parts. On the grid, draw the lines 1, 2, 3, and x is less than 4, y is less than 3. Yeah, it is same. And label it as R. The only difference is to label.
So should I do that one as well?
Try this question number 4. I'll just number them for easy communication. And the third one dotted. Which one are you looking at?
I'm looking at number 1.
Okay.
So y is less than or equal to x plus 4.
There's one mistake.
Negative x. Yeah, negative x plus 4.
Negative x.
Negative x plus 4. And then number 2 is just, yeah, y is, yeah, no, y is more than or equal to 2.
And this is completely wrong.
Oh, x is more than, yeah, x is more than or equal to 2.
More than
Because they shaded the,
r is to left hand side.
oh, because they shaded the more than region, so there has to be less than, right?
When we are writing about the region, this is the correct equation. X is less than equal to 2.
Mhm.
And they are actually shading the undesired region.
So
We
yeah,
have to write the
more
equation
than region.
for the region.
So since it's less than, so it has to be more than, right?
Shading has to be more than, but the
Yeah.
equation is x is less than 2.
Yes. And then number 3 is, so it's 2x. Wait, is y is more than 2x plus 1. Y is more than 2x plus 1.
Yeah. And I didn't give it a thought. Actually, there's a different line. You see, these three lines are not defining this region. Line 2 is actually useless. This should be the third line, which is x is greater than
0.
equal to 0. So 1, 2, and 3. These three are defining the region. Getting
So
it?
sometimes we'll ask us to like see which line is like not important and draw like a
I,
line that's
I,
important.
I, I think this is some sort of typo or printing error. This
Oh,
line should have been here
yeah.
because these are the three boundaries of this region. Now, before we answer this question, how many boundaries are there for this region?
There's 3.
Yeah. So it says the unshaded region in the diagram represents the set of inequalities 1, comma 2, and 3. So the 3, but this region is like 4 sides. This white region is 4-sided shape. So we can actually write 4 inequalities. And he's again giving 3, 1, 2, 3. Write down the pair of integers that satisfy all the inequalities. Now, pair of integers x, comma y. Choose any one,
So
which would
it's
satisfy all these 3.
1 and 2.
x1, y2. So you're selecting this point 1, comma 2. So it could be anything between these. This is correct. I'm just highlighting what possible answers could we have. We could have 1, comma 1. We could have 2, 1. We could have 3, 1.
And also 2 comma 2.
Sorry. Dotted line, this is not included. And we could have 0, comma 2 because this is included in 0, 3. And that's it. And these 1, 0, 2, 0, 3, 0. Safest of all are these 3. Only the dotted line is not included. All others are there. Question 6 is again practice. I'll share a worksheet with you apart from this. And linear programming is actually very easy topic. Just the name given to it, a fancy name, programming.
It's basically the same thing.
Basically the same thing, actually linking it with the with any real example, as we did for the toy factory, for example. Quickly, if I'm making a toy that actually costs me something, there are some fixed prices. Even if I'm not making any toy, I'm just paying the rent, or I'm paying the wages, or I'm paying the bills. So this is at zero toys, I'm still paying something. At one toy, now the cost is increasing because I'm buying the raw material. Now I'll sell one toy for some price. I'll sell a second toy for some price. I'll sell a third toy for some price. Fourth toy for some price.
And then
So
where they intersect.
this would be, yeah, the point where it intersects is that number of toys. If I'm able to sell them, I will be at no loss, no profit. More than that is profit, less than that is a loss. So this is linear programming. For example, we've done this analysis and this point comes out to be 2,500 toys. Now, this is something the person who was given this task, he did that calculation. And then there's another person who tells them that the region where you're selling toys, and the population says that there are only 450 children. So before putting your factory or making that your target region, you will give a big no to this region, because you need to make 2,500 toys in order to make a break even. And there are only 450 children.
That's why you should add another region to it, sell it to another region as well.
Or maybe entirely target a different region and target something else for this place. Or maybe a high value product.
Mhm. So that's linear programming. You're just trying to find the point where you won't make any
Here,
profit or loss.
linear programming is only this inside this yellow circle.
Okay.
It could be applied to anything. For example, if I tell you that we are making plates and cup from like um, these are mud plates and cups. So let me tell you that if you make a cup, you will use 1.2 pounds of mud. And if you're making a plate, you will make 0.7 pounds of mud. So you know you what total you have 20 pounds. So what we can do is we can make that linear programming, that if I make plates, how many would I use? If I make cups, how many would I use? And this is the total. And then definitely there's a second thing to it, that the plate would sell for, let's say, $1, and let's say this would sell for $2. So what will you invest in? And so we can do this with the equations. Just a second. Getting the idea? These are just straight lines.
Yes.
So if we look at 14.7, it says in the diagram, let me just remove this. So in the diagram, the unshaded region represents the set of inequalities. X is less than 6 and less than 6. So this is the line 6, and less than is to left of it. And then we have, these are two inequalities. Y is equal to 0 and y is equal to 6. So this is y equal to 6 and this is y is equal to 0. So it is less than 6 and more than 0. So below 6 and above 0. The last one is x plus 4. And I'm thinking about y is greater than equal to minus x plus 4. So I see a negative gradient and y-intercept is c. So this is my line and y lies on top of it. So yes, the region is well defined. And what does it say? Find the greatest and least possible values of this subject to these inequalities. So we know we cannot select anything out of this box. So I have to work out greatest and least. So my first instinct tells me to go for these edges, like -2 comma 6. This is 6 comma 6. This is 6 comma 0. This is 4 comma 0,
Probably
and so
six.
on. Now for maximum, I think 6 comma 6 clicks me more. 3 into 6 plus 2 into 6 gives me 5, 6 times is 30. And then for the least value, let's
Probably.
try 0 and -2, 6.
Sorry?
Let's try -2, 6 and 40. So when I try 40, so it's 3, 4 times is 12 and y is 0, so I'm getting 12. When I try -2, 3 into -2 is -6. 2, 6 times is 12, -6, so I'm getting 6. So this is giving me least value. So greatest is this and least is 3 into -2 plus 2 into 6. -6 plus 12 is 6. So this is what I'm getting, greatest and least. Yes. I was just wondering if I'm getting any other options. So this is least and greatest.
So the edges are what we need to look for.
Yes. They will give you the maximum or minimum values. Or we should say the intersection points. Because if I just see this 2 comma 2, this is giving me 3, 2 times is 6 and 4, 10. So this is actually in between maximum and minimum as well. So
Hmm.
3x plus 2y, out of this, greatest is 30 and least is 6. Number 2, on a grid shade the unwanted region same, and then B part looks like the first one, greatest and least values. The whole number x and y satisfy the inequality. This is find the greatest and least. Okay, so this is linear programming. I'll share these 4 questions along with answers, or these 3
Yeah.
along with, and one more worksheet.
Okay.
These 3 for today, and I don't know if we are having class tomorrow or not. I might be available.
Mm-hmm.
I'll ask Sir Kashif if it is on schedule because I just got a message in the group. Let me
I
quickly
think I
check
got
it.
like a similar email from my dad. It was like the times are changing for the classes.
I'll quickly check what it was. It says 16, 17, and 18. So tomorrow is 16 on account of Eid days.
Mm-hmm.
But for now, we'll stick with what the organizer says. If there's any change, I'll personally inform you.
Okay.
I'll text in the group and as email. If there's no notification, we'll stick to the plan.
Okay.
Okay. And currently, I'm sharing these 3 questions with you.
2,
Okay.
3, and 4.
2, 3, 4.
And a
Any,
worksheet, right?
yeah, I'll have a look at it. If there's anything missing, I'll hold it. If we've covered that part, I'll share it.
Okay.
Anything else you would like to ask?
No.
Okay. And I'll also share this entire topic so you have these solved worked examples as well. and one worksheet.
The
Okay,
other one was just the whole chapter.
I'll come to that. Anything you would like to ask from this worksheet?
No,
Was it clear? Very good.
yeah, it was
And
all good.
all of these, I think, answers were not there in this sheet.
Mm. For the first one, there were, but for the second one, no.
Okay, so do you want me to go through this quickly or were they clear?
They were pretty easy, honestly.
Very nice. In the second diagram, we had 5 lines.
Yeah. Oh, yes, for that one, I wasn't really like 100%. I mean, maybe not. Yeah, I wasn't really 100% with which one actually enclosed the shape.
I'll
So,
quickly get through this.
yeah.
So the question says write down the observation. By observation, the equation of lines which has enclosed shaded region in the following two figures. So
So,
within this second one, if you can see, this is a 5-sided shape.
mm-hmm.
So we need to write 5 lines, 5 equations or inequalities. It is advised that we always continue start with the horizontal and vertical ones. So if I look at this vertical line, it is all the way x equals to 0. And I can see the region lies to right side of this line. So the equation to inequality is x is greater than equal to 0. Equation was x equal to 0. Now the second vertical is at 5. Equation is x is equals to 5. And we can see that the region lies to left of it. So x is less than equal to 5. Two equations done. The third one, which is horizontal, is right here on x-axis, and throughout y is equal to 0. So this is the equation, and the region lies above this line. So it has to be y greater than equal to 0. When we are done with these three, vertical and horizontal, I'm coming to this line. Now, when it says by observation, it would definitely depend on your practice. So I can see that rise over run is 1:1. So y
So, yeah.
equals mx plus c. I can see the gradient is 1 and y-intercept is 2. So equation for this straight line is y is equals to x plus 2.
Yes.
Now, the shaded region lies below the line. So it
So
has
it's
to
going to
be
be
y
more.
is
Oh, so the
less than.
only, yeah.
We are talking about the shaded region. When it says leave unshaded, then it is the reverse. Now the last line, the one
Yeah.
in green,
That's also
again
the,
it is 1:1. The gradient is negative. So y is equals to negative x and y-intercept is plus 6. And this goes the equation and region lies below this green line. So y is again less than equal to 6. Less
okay.
than equal to minus x plus 6.
Can I quickly copy this down?
Yeah, sure.
Okay.
Okay, so I'll scroll up. This is like the fun part. When it says leave unshaded, it is pretty easy to rule out the other area. Identify the region by unshading defined the following inequalities. So if I talk about this y is less than equal to k, whatever it is, the region is below the line. So when I leave it unshaded, I have to shade the other side.
And also for the
Clear
exam.
with the first line?
Sorry?
Clear with this first shading?
Yeah.
Then the second one, let's say this one. So it is clearly above the line. So I have to rule out whatever is below the line. Then the third one is again above the line. So we rule out which is below the line because it said leave the actual area unshaded. And this is our region.
Yes. Okay.
Now notice that both of these are the lines are exactly same, but only the inequality changes. So you'll see the shaded area changing. You see, it was in between these lines, making a triangle. Now this one right here, the lines are same, but we will shade on depending on the inequality. So it is less than k. It says leave it unshaded. So I'm shading the upper part. Now it says it is less than. So actually the region is below the line. So we're leaving it unshaded means shading the upper part.
So that
Again, it
means not
says
the first
more.
one. So more
It
than
says
zero.
more than. So this is the region, and we shade below that. And you see, after ruling out, this is the region which is left behind. So this is our desired region defined by the given inequalities. Same question continues, so we'll follow the same statement. Quickly shading above the line, some ruling out the region below it.
Yeah, these questions
Why
were
is
very easy, especially because it
okay?
was just like shading and stuff.
Yeah, I'll just complete this and then I'll move on to the questions you wish to solve.
Okay.
Greater than 0, so we rule out this. Greater than upper side, so we rule out the lower side. And this is the region which is left behind. Okay, I'm just scrolling up. Let me know where you wish to discuss. I think that's a misprint. Were these clear?
Yeah.
No? Like you want me to discuss these?
No, they were clear. Yeah.
Okay. Okay, so this sheet is done. And there was already no question in this one.
Yeah. That one was just 2, 3, 4, and 5. And then that was it.
Yeah.
I was
Now
just a
we
little
have,
bit stuck on 4, but then I got it. It's because it helped me get question 5 as well. But yeah.
that's very good. Now, having done, we will be moving to next topic, which is completing the square form. So we have quadratic equations, and we will convert them into completing the square form. And let me just copy this. This is x minus 2 whole square. So we'll solve this and then do the reverse of that. So for example, we have this x plus 2 whole square. Do you remember this? A plus b whole square equals
Mm-hmm.
a square. plus 2ab plus b
That's
square.
me squared.
Second was a minus b whole squared, that is a square minus 2ab plus b square. And the third one is a plus b
A minus.
into a minus, that is a square minus b square. So this is a plus b whole square, and if I open that directly, this is a square plus 2ab plus b square. So what actually we'll be doing is we are going to convert this right hand side to this left hand side. So this one is completing square form. Okay.
Okay.
So I'll do this exact one which is right in front of us, the reverse of it, and then we'll practice more. After doing this, or else let me tell you the rules first. First step is coefficient of x square equal to 1. Second is add and subtract the square of half of coefficient of x. And third is close the square and simplify the remaining. Now see the first step. Luckily, it's already done. The coefficient of x square should be 1. That is already 1. The second step says add and subtract the square of half of coefficient of x. So I can see the coefficient of x is 4 right here. The coefficient of x is 4, half of which is 2. So adding and subtracting, this is what I'm going to do. So we write x square plus 4x, and then I add 2 square and subtract 2 square. This. Can you compare these two lines, first and second?
Well, the plus 2 squared and
Mathematically,
minus 2 squared cancel out. And then it's the same thing.
mathematically, exactly. We are just copying these, and this is something extra. Adding and subtracting the square of half of coefficient of x. Now, what do we do? I'm going to close this square. If I just look at this, may I say this thing which appears like this x square plus 4x plus 2 square, this just looks like that this is actually a square, this is b square, and this is 2ab. So basically, this is we copy this x, we copy this positive sign, we copy this 2 and whole square. And on the other side, this is minus 4 plus 4, and this becomes x plus 2 whole square, so completing square form.
So we take the 2, and then we take the x. And then,
Yes.
okay.
I'll just quickly do 2-3 examples, and it will be very clear within like 5 to 6 minutes. Let's say the question is x square plus 4x plus 5. So first step, coefficient of x square needs to be 1. It is already 1. Second step, x square plus 4x plus 5. And what do we do? Coefficient of x is 4, half of which is 2. So we add 2 square and we subtract 2 square. So plus 2 square minus 2 square. Now we close first 3 and solve last 2. So I'm copying this x, I'm copying this positive sign, I'm copying this 2 whole square minus 4 plus 5. So simplifies to x plus 2 whole square plus 1. So this is the completing square form for this first step. Another question. X square plus 6x plus 9. Now without going into discussion, let's do it directly. X square plus 6x plus 9. Node of working, we know we need half of x. So it is plus 3 square minus 3 square. And then what do we do? First 3 and
Yes.
last 2. So we copied x, we copied the positive sign, we copied this 3 whole square minus 9 plus 9, and this is x plus 3 whole square.
That's it.
Let's see, x square minus 6x plus 10.
And that would be plus 1.
That's right. So I can see this 6, but I will always write plus 3 and minus 3. Half of x, and first one is added, second is subtracted. We cannot change this order. So we copy this x, we copy this negative sign, we copy this 3 whole square. You see, if we expand this, you'll actually get these 3 back. This is a minus b whole square. Then minus 3 plus 10 is x minus 3 whole square plus 1.
Okay.
Now let's try something which has a coefficient other than 1. So 2x square plus 12x plus 5. Mm, I'll keep this 5 for later. Plus 10. So we copy 2. This is x square plus 6x plus 5. First step is we make the coefficient of x square as 1. Now everything is repeating itself. So 2, this was x square, this was 6x, and we knew coefficient of half of x. So plus 3 square minus 3 square and plus 5. Now we do our job, that is first 3 and last 2. So close the first 3, that is x plus 3 whole square minus 9 plus 5. Keep on simplifying. You get 2x plus 3 whole square minus 4. Now we can bring this 2 inside. So 2 into x plus 3 whole square minus 8. So this could be written as this in completing square form. There are many uses, and this completing square form is actually a lifesaver. This will be used when we need to sketch the curves. We can directly tell either the curve is smiling face or sad face and what the turning point is. Other than that, if I just tell you, if I just copy it, let me do that. 2x square plus 12x plus 10 is equals to y. If I tell you to make x the coefficient, make x the subject of the formula. So it is not possible without making this shape. Because you see, x is at two places. One is squared and one is single. You cannot make it subject. But if you convert it into completing square form, now see x is only at one place. Now it is very easy to make x the subject of the formula. Y plus 8,
And then move it
y
down.
plus 8 by 2 and square root both sides. So x plus 3 and x is equal to minus 3 plus minus square root y plus 8 by 2. Getting it?
Mm-hmm.
Okay. Now let's see what our scheme of work is. So first thing was completing square. We just went through the process. And here are a few examples. X square plus 6x plus 14. Give a quick try to this. I'll also solve with you. The first one, 1a. X square plus 6x plus 14.
Okay. I got x plus 3 squared plus 5.
That's right. Let's try F part. Is it readable?
Mm-hmm. X minus 1 whole square minus 18. Yes.
Very good. Very good. Let's try H part, K part. X minus 13x plus 1. This is your choice. You want to keep them as fraction or as decimal numbers. I always keep them as fractions.
Oh,
Both are acceptable.
okay. I did decimal, so yeah, I got x minus 6.5 squared plus 43.25.
Why you're getting 43? It should be 41 because we have a negative sign with like 13 by 2 square and then that's a plus 1.
I'm just going to redo this.
Yeah, look at this second last sign. That should be negative.
Oh, I see. Yeah. Okay, so it's gonna be minus 41.25.
Yes.
Okay.
Okay, now this second part says solve them. First, we were just completing the squares. Now, second one is expecting to solve for x. First, they were expressions. Now it is an equation. And it says giving a final answer to two decimal places. First one, x square plus 6x minus 5 equal to 0. One more benefit of this completing square form is that we don't always get like midterm breaking. Definitely, you can also try quadratic formula. But when the examiner restricts you that by which method, we have to follow it. So x square plus 6x plus 3 square minus 3 square minus 5 equals to 0. Now we close it. X plus 3 whole square minus 9 minus 5. X plus 3 whole square minus 14. X plus 3 whole square equals to 14. Square root both sides. So this is x plus 3 is equals to plus minus square root 14. And x is equals to minus 3 plus minus square root 14. Now I'm using calculator because 14 is not a perfect square root. So minus 3 plus square root 14 gives me 0.74 to two decimal places. And minus 3 minus square root 14 gives me negative 6.74 to two decimal places. Are we getting same answers?
Oh, I wasn't also solving it. I was just watching you solve it, but yeah,
Okay.
I'll solve it.
Now if we
Yeah.
solve another part. So let's try this B part. X square plus 8x plus 4 equals to 0.
So x equals to -4 plus or minus square root 12. So final
That's
answer
right.
would be x equals to -7.46, right? Or yeah, because square root 12 is -0.54, and then -4 plus that would be -7.46.
Yes.
Okay.
Okay. So number 3. Solve each of the equation by completing square. I can see that the first two are simple forms. And let's see what C part has to say. The C part says this is x into 6 plus x is equals to 1. Always make the quadratic equation first before going towards completing square. So 6x plus x square is equals to 1. Now we rearrange x square plus xx minus 1 equal to 0. Now we can repeat all the steps. X square plus 6x plus 3 square minus 3 square minus 1 equal to 0. So x plus 3 whole square minus 10 equals to 0. Rearranging, taking square root on both sides.
Okay. Hello?
Are we getting same answers?
Yes.
Very nice. Let's see E part, elephant.
Okay.
5x is equals to 10 minus 1 by x.
Can I just see how you're doing this one?
Yeah, sure. You want me to scroll up?
Yes.
Just the second last step. एक विजिट करें हम ठीक है फिर पसंद आया तो फिर आपको and 0.101. Okay, basically what I did is first I just directly multiplied the whole equation with x. I didn't go for LCM. I did this
Mm-hmm.
first step to get rid of that fraction. So I'm getting 5x square plus 10x minus 1. Second step, I rearranged and got this third one. Now I knew that I need x coefficient of x square as 1, right?
Mm-hmm.
So
So you
what
did.
I did is I divided this whole equation with 5
Oh.
because this was an equation. Difference between equation and expression, 5x square minus 10x plus 1. When it is an expression, it is not equal to anything, then I'm bound to do this. But when we have an equation, we can take this 5 on the other side and write x square minus 2x plus 1 by 5 equals to 0.
What do you mean by take the 5? Do you mean like instead of 0, it's 5?
Is 0 divided by 5.
So yeah, okay, so still 0. So just the whole equation divided by 5. Okay.
Yeah. Expression versus equation. For example, we have 5x plus 10. That's an expression.
Mm-hmm.
And if I have 5x plus 10 equal to 0, that's an equation.
So an
Now, in
expression
case of
is
expression,
something,
I can do nothing.
yeah. Equation, you can solve it.
Yes. So I just directly took 5 on the other side, made
Mm-hmm.
5 common, and took it on the other side. Or we
Okay.
can say that dividing by 5 on both sides. This one, dividing by 5 on both sides. So it made it 5 times less each expression.
Mm-hmm. Okay.
In order to get coefficient of x square as 1. And then these are the same usual steps.
And then when you did it for x equals to on the last one for the screen, last step, you did 1
Yeah.
plus. So you did both ways. So you have to do both ways for every time you do it.
Yeah, when I got this quadratic equation, this one right here, that
Mm-hmm.
is x square minus 2x plus 1 by 5 or 0.2, then I had my normal steps, which
No, no,
was
no. Yeah, yeah.
this one,
Yes. No, no, no.
adding
I
the
don't
coefficient
mean
of
that part. I mean the very, very end, like the last
with
step,
the end,
not the
the
like
one
the
in green.
answers. X equals to 1 plus square root 4 over 5, and then
Yes.
1 minus. So for that one, we have to do both ways, right? We have to do 1 plus square root 4
Yeah,
over 5 and
always.
this.
Whenever we take square root both sides, that is plus minus.
Okay.
See this difference? If you have t is equals to square root 16, this is your answer.
Yes.
And if you have t square is equals to 16, this is your answer. Now,
Mm-hmm.
what is the difference? When we have t square is equal to 16, we do this.
Oh, yeah. Because
Square
it can
root
be either
both
positive or negative 4. It's not clear.
yes.
Yeah.
Yes. So when it is single, this that is always positive. When it is square root both sides, that is plus and minus.
Okay.
is similar to this. Let's go through that quickly. Question number 3, part F. X minus 5 equals 2 by x. Let me know when you copied the question.
Yes, I got it.
Okay.
X equals to plus or minus 2.5. Yeah, the square root of 4.5. So that would be
Yeah, we have to be careful with the two decimals wherever it is required,
so
and
this
the
one's
rounding as
the
well.
one you solved, right?
Yes. Let's try. Are we getting the same answers?
Just checking that. Mm, no, we're not.
What's the difference?
Uh, I still got the 2.5, but inside the square root, I have 4.5.
Okay. That is 33 by 4, which is 8.25. So square root of that is 2.87. And then we add 2.5 to it.
Yes, but I did not
We get,
get. I didn't get 2.87. I got 4.5. Not as my final answer, but inside the square root. So I'm just gonna read through that to
inside the
see.
square root, are you getting 33 by 4?
No.
Make sure you're punching it right in calculator. 33 by 4 completely is under the root.
Mm-hmm. Can I see your steps and compare them to mine?
Yeah, sure. It starts here.
Mm-hmm. How did you get 25 over 4? Did you solve the
Last
problem?
two expressions, 25 by 4 and 2.
Mm-hmm. I'm talking about your fourth step. So, yeah.
These two.
Mm-hmm.
Just punch them in calculator. 25 by 4 plus 2.
No, no, no.
You'll get 30.
I'm saying, how did you get it from step 3?
Okay. Let me just quickly number them. The first one is clear, second is clear, and third is clear, right?
Mm-hmm.
Now the next step. You see, these are just copied.
Yes.
And then we have this add and subtract thing.
Mm-hmm.
Now, when we move further, we needed to close the first three. So this is the x, this is the negative sign, and this is 5 by 2 whole square. Then 5 by 2 is actually 25 by 4 when we open that square with a negative sign.
Oh, so we have to, okay. So
Yeah.
we
So
start with,
negative 25 by 4
yeah.
and negative 2. Now these two, negative 25 by 4 and negative 2, is giving us negative 33 by 4. I just use this in calculator directly.
Mm-hmm. And then 33 over 4. Okay. I don't think I squared mine, so that's why. Yeah, that's the reason why I didn't square the 2.5. Okay, I see.
Okay, okay. Okay, that's how you're getting 4.5.
Mm-hmm.
Basically, the concept is clear. That was a small mistake.
Yeah.
Okay, now this G part, that's a bit different. X minus 1, x plus 2 minus 1 is equals to 0. So we'll always convert it into quadratic form first. X minus 1 into x plus 2 minus 1 equals to 0.
Sorry, how did you get 1/2 for step 3?
Okay, the where it
One.
finishes with blue.
Yes.
Half of coefficient of x. You see this x? Coefficient is
Mm.
1. So half of that. And then we add and subtract.
Okay. So your coefficient was 2. No, your coefficient was x. So you first open the x minus 1 and
Variable
x
is
plus
x.
2. Sorry?
Variable is x and its
Mm-hmm.
coefficient is 1.
Mm-hmm. It's 2x minus x. Okay, with x minus 3 and x squared. Okay, okay. Good. And then can you scroll down?
Yeah, sure. We basically just have to follow the steps slowly, avoiding any careless mistake.
Yes. And then, okay. 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 Got it.
Okay. Are you familiar with this quadratic formula?
Yeah,
The one at
we mentioned it, but I'm not like too familiar with it. I know it.
okay. We'll use it shortly. Solve the following quadratic equations giving answer to three significant figures, and now we're going to solve this by using quadratic formula. So if we have an equation where it says ax square plus bx plus c. So minus b plus minus b square minus 4ac over 2a. So basically a is the coefficient of x square, b is the coefficient of x, and c is the remaining constant. For example, the first question is x square plus 4x plus 3.
So A is 1, B is 4, and C is 3.
Right, a is 1, b is 4, and c is 3. So now we just plug them in and solve. So minus b plus minus square root b square minus 4 a c over 2 a. You can also punch this completely in calculator or do 1 to 2 steps.
So two answers, -4 and 0. No. Okay, I got something different.
I'll also recheck quickly. Minus 4 plus square root
Yeah,
b square
oh, okay, I
minus 4
see.
in
Yeah, -3 and then -1. Okay, so -4 plus or
yeah, I'm
minus
getting
2.
3.
Yeah, same answer as you. -2 and then 2. -6 over 2 and then -2 over 2. So -1 and -3. Okay.
Another minus 7x plus 11.
B?
B part.
Okay.
Yeah. Got it?
Doing the second part, but yes,
Okay.
2.38 and then 4.62. Okay. Oh, so yours doesn't have the negative sign? Oh, Wait,
No, I
what
didn't
did you?
get a negative sign.
No. What did you do to the -7?
See,
Oh,
minus b
because it
actually
was
changes that into +7.
yeah, because it was already -7, so that's why. Okay.
Yeah.
Okay, but my answers are still correct. It's just I put a negative on mine because I thought it would stay -7. But yeah.
This is basically just plug and play.
Yeah.
Okay. Each of the following quadratics will factorize, solve each of them by factorization, and then use quadratic formula to show that you get the same answers in both cases. So basically, we are going to do the same question with completing square form
Mm-hmm.
or midterm breaking, and quadratic formula is compulsory in this part.
What was the second part? Method?
Middle term breaking. Yeah, I'll show you.
Okay.
Splitting the terms basically. X square plus 7x plus 12 is equals to 0. Now I know that plus 3x and plus 4x will give me 7 when added.
Oh yeah. Oh, I see. I remember. Okay.
Splitting. So when we add these two, we get 7. When we multiply these two, we get 12.
Okay. I got it. Okay.
So x into x plus 3, and then 4 common, x plus 3,
And then it's just x plus 3 and then x plus 4.
x plus 4, x plus 3 equals to 0. So
Yes.
it gives me x is equals to -4 and x is equals to -3.
Yes.
Now doing the same question with quadratic formula. Minus b plus minus square root b square minus 4ac over 2a. So b is 7. 7 square is 49. And minus 4. A is 1. C is 12 by 2 into 1. So minus 7 plus minus 49 minus 48 over 2 minus 7, that is 1. So plus minus 1 by 2 minus 6 by 2 and minus 8 by 2, which makes it minus 3 and minus 4. So
So
yeah,
both
we
correct.
do get.
So this is kind of like a method of double checking yourself.
Yeah, but in exam we'll always do with one method.
Okay.
There
If we
will
want to
be
check our
no restriction.
answer, if we want to check our answer, we can use a different method though.
Yes, we can do that.
Mm-hmm.
Okay, so these are just the practice questions. Can you just quickly give a try to G part, garden,
Mm-hmm.
and see if you get the same answers?
Which method do I use?
Both actually,
Okay.
splitting and quadratic formula. Splitting is basically factorization.
Mm-hmm. I did the quadratics, but I don't know how I'm supposed to do like the splitting the numbers.
Are you getting these answers? 4 and 2?
I'm getting 5 and 1.
5 and 1.
Yeah.
Okay, let's check with quadratics first. I think I did it mentally. I'm getting 4 and 2. Let's see. This is x square minus 6x plus 8 equals to 0.
Mm-hmm.
Minus b plus minus square root b square minus 4ac over 2a. Minus into minus 6 plus minus square root minus 6 square minus 4ac over 2a.
So 6 plus
So
or
this
minus 4.
that is 4 8 times is 32.
Mm-hmm.
So 6 plus minus 36 minus 32 is 4.
Mm-hmm.
Plus minus 2. So one it is 6 plus 2 by 2. The other it is 6 minus 2 by 2. 8 by 2 is 4 and 4 by 2 is 2. So we're
Oh,
getting
I know
4.
what I did. I think, yeah, I know what I did. Oh my God. So I basically, instead of like, I knew that it was square root 4 and the square root 4 is 2, but I continued to add 4 with 6. So,
Okay. Okay.
yeah.
So just remember this whenever we are making a mistake, that is when we just do it a bit quick.
Yeah. Okay.
And now I have to think of two numbers. When I add them, I should get minus 6. And when I multiply them, I should get 8. So when I'm looking at 8, I know that 1 into 8 is 8, but adding or subtracting these two is not giving me 6.
Mm-hmm. So 4 and
Try
2.
2 and 4.
Yeah.
So when I add them, I do get 6, and I need to adjust those signs. Both will be negative. So x square minus 4x minus 2x plus 8 equals to 0. Now I know that when we add these two, I get minus 6. When I multiply these two, I get plus 8x square. If this would have been 2, we would have been solving for 16. This is 1 already. So now we take out common in first two, x, x minus 4. Then we take out common in second two, minus 2 into x minus 4. So x minus 2 into
X
x minus
minus
4 is equals to 0. And first bracket equals to 0. Then second bracket equals to 0. So x is equals to 2 and x is equals to 4.
Okay.
So I think take a screenshot. No, I'll send it with answers.
Okay.
All this requires is some written practice.
Mm-hmm.
Quick look what is left out of this. Hmm, okay. Yeah, I'll share this complete exercise 14.9 along with answers.
Okay.
And just do the practice, then we'll be good to go.
Yes.
Anything you would like to ask? Anything you want me to repeat?
Um. No. No, I'm good.
Sending the practice. Question number 6.
Yes.
It says a biologist claims that the average height H meters of a tree of a certain species after T months is given by this given equation. For this model, find the average height of the tree's species after 64 months. You just have to plug in 64 in place of T.
Mm-hmm.
So it will be 1 by 5, 64 raised to the power 2 by 3 plus 1 by 3, 64 raised to the power 1 by 3. That's 1 by 5, 64 cube root is 4, square is 16. 64 cube root again is 4. So I'm getting 16 by 5 plus 16 by 3. And this is 16 by 5 plus 16 divided by 3 is 128 by 15.
So 64 to the power of 2/3 and 64 to the power of 1/3 is both 16.
1/3. No, that's 4.
That's 4. So that
That-
is okay.
it- Basically, cube root of 64 is 4.
Mm-hmm.
And so for the first one, when it is 4, 4 squared is 16. This is 8.53. And B part says find to 3 significant figures the number of months that the tree have been growing when the model would predict the average height of 10 meters. So now we just place 10 here. And this is 1 by 5 t 2 by 3 plus 1 by 3 t 1 by 3. Now you have to recognize that this is a quadratic equation, or it could be converted into quadratic equation. How? If I just suppose that, let's say t raised to power 1 by 3 is equals to x. So may I write 10 is equals to 1 by 5 x square plus 1 by 3 x. Any objection?
No.
Now I'm multiplying with x on with 5 on both sides. 5 3 times 15 on both sides, because 15 is LCM on right hand side. So this is 150 is equals to 3x square plus 5x. Now we rearrange 3x square plus 5x minus 150 is equals to 0. Now there's no restriction in the question. And this one thing, 3 significant figures, ensures that it is going to be in decimals. So I'm directly going for quadratic formula. Minus b plus minus square root b square minus 4ac over 2a, where b is 5. This is 5 square minus 4 into a into c is negative 150 whole square root over 2a. So minus 5 plus square root, that's 25, minus 4 into 3 into minus 150 over 6. 1 it is 6.29, and with the negative sign it is minus 7.95. Now this is x. When I need to find t, I need to substitute the values here. Now one thing is very clear, that 6.29 is equal to t raised to power 1 by 3. On the other side, minus 7.95 is equal to t raised to power 1 by 3. I'm rejecting this because we know time cannot be negative. Then we take cube on both sides. So t is equals to 6.29 cube is 249, rounded to 3 significant figures. Months. Clear?
Yes.
Doubt? We can discuss it again if there's any doubt.
Could you do the equation again? Are we like the green?
Yeah. First of all, this is minus b plus minus b square minus 4ac over 2a, quadratic formula.
Yes.
Secondly, then we plug in the values where a is 3, b is 5, and c is negative 150. And then I punch this in, calculate it directly.
Okay.
I could have rejected this right here, but I wanted to show you that these are actually the values of x, and x is equal to time something, time raised to power 1 by 3, and which cannot be negative.
So it had to be the positive.
Had to be positive.
Okay.
Yes. I'm repeating this because sometimes students confuse this when they are getting two answers. Let's say one is 2, the other is minus 3. Subconsciously, they just write rejected with negative 3, unknowingly that what it is. If that is temperature, that is quite possible. Temperature could be negative. So
But yeah.
if it is weight, cannot be negative, price cannot be negative, time cannot be negative. So we have to see that. Okay, let's see where we were. Okay. Factorizing quadratics where the coefficient of x square is not 1. We've already discussed it, and we have to go through some practice. Depends if there is any restriction in the question, or we can choose our own methods. So this is 2, 3, and 1. Two, 3, and 1. So that's an expression. It is just the factorization and not values of x. So you see, when we have the quadratic equation, we always multiply these two, the first one and last one, provided it is already arranged. Square term is first, then we have x, then we have constant. So basically, product should be 2x square into 1, which is 2x square. And the sum should be the middle term.
So 3x.
So sum should be 3x. Now I have to think of two terms. This is 2x square already, that is plus 1. So in order to get the product 2, we know 2 is 2 into 1 only and no other thing. So I have to adjust these two numbers, adjusting with positive 2x and x. Now when we add these two, we get plus 3. And when you multiply these two, you get positive 2x squared. So the factors are acceptable. Now we take out common from first two, which is 2x, and I'm left with x plus 1. And on the other side, plus 1, x plus 1 again. X plus 1 is same bracket in both sides. Then I have 2x plus 1. Clear?
Yes.
Let's take the second example, that is 3 minus 14 and 8. 3 minus 14 and 8. Now again, multiplying the first and last, product should be 3x square into 8 is 24x square. And the sum should be minus 14. That product is 24. Sometimes you may click directly which the numbers are. So I'm just thinking 1 into 24 is 24. 2 into 12 is 24. And meanwhile, what I'm thinking is when I add and subtract 1 and 24, do I get 14? I'm not getting it.
So
But
second.
second one, yes.
2
Or
and 2.
else we know 3 into 8, 4 into 6. But adding, subtracting is not giving us 14. So we select 2 into 12. And do not forget, we also have to adjust the positive negative signs. Both the conditions must be fulfilled. So minus 2x minus 12x plus 8. Adding these two is giving me minus 14. Multiplying these two is giving me positive 24x square. So taking out common from first two, 3x, I'm left with x only. I'm taking out x, so I'm left with 3x minus 2. And on the other side, I'm taking out minus 4, so 3x minus 2 again. So this is x minus 4 into 3x minus 2, and it is factorized. Now try the third one with me. This is 10x square plus 11x minus 8. Now what should be the product?
It should be 80x squared.
80x square with the negative sign, right? And the sum?
And 11x.
11x. So take your time, think about the factors.
16 and 5. So 10x squared plus 16x minus 5x minus
Very,
8.
very good.
And
Now we take out common. I can see this is 2x. I'm left with 5x plus 8. And then minus 1, 5x plus
plus
8.
8. Okay. So it's just 5x plus 8 and 2x minus 1.
Yes. Okay. When they tell us to factorize, we do not have any other option but to go for middle term breaking. But when they'll tell us to solve, then we have multiple options. First is this middle term breaking, then it is equal to 0. Second is completing square form. That is the longest, that is the last option we'll go for. And then we have quadratic formula, which is the easiest because you just have to plug in the given formula, the given values in the formula. Okay. Practice exercise. Factors each of the following expressions. I think we just did this, but there was negative 14. This time it is positive 14. Mhm. Let's try this B part. 2x square plus x minus 3.
So 2x squared plus 3x minus 2x minus 3. I think, yeah.
2x square plus 3x minus 2x minus 3. Adding them plus 1. Multiply. Very good. So this is the final statement. Do we have the same answer?
Oh, I wasn't
It,
finished yet, but
take it. It could be this way as well. That is just the different arrangement.
so 2x plus 3 and x minus 1. So yeah.
Yes. Okay, let's see C part. 6, 1 and minus 2. 6x square plus x minus 2.
So 6x squared plus 4x minus 3x minus 2. Then factorizing. Okay. So 3x plus 2 and 2x minus 1.
That's right. Okay, D part. 3x squared plus 14x plus 16.
Oh, so 3x squared. Yeah.
We getting same answers?
Uh, I'm not finished yet.
Take it.
Okay. So x plus 2 and 3x plus 8. Yeah. Okay. Same answers.
Very good. Now let's see if we can find something a little tricky. 2 and 10. Okay, can you look at E part 2, -1 and -10?
Mm-hmm.
So that is 2 into 10 is 20 and -20. So I'm thinking midterm would be -5 and +4.
Mm-hmm.
Do you agree?
-5 and +4. So
Yeah. So now let's just save some time and we'll discuss the main thing. Remaining is just taking out common. So 2x square minus x minus 10. So if we solve this, this would be 2x square minus 5x plus 4x minus 10. So when multiplying this, it is giving me -20. When adding this, it is giving me -1, right?
yes.
So I'm just saving some time in the simplification. This is the main step. Now 16x square plus 32x minus 9. What would be the factors?
-36. Wait. So am I? Yeah. Okay. I looked. I was looking at your screen, so I didn't really do it myself. So
No issues, no issues.
okay.
This is a practice class. So I always prefer this method.
Just
And
listening back one, two, and three.
there's one more method you can do, which is, let me show you. That is if we multiply these two, this is 144. So we take the LCM 2, 72, 2, 36, 2, 18, 2, 9, 3, 3, 3, 1. Now we know that whenever we multiply this, we'll always get 144. So we try different combinations of these, which could be 2 into all this, that is one combination. Other could be 4 into all this, and so on. So we just retry. So one way is this, the other way is this. Both are acceptable. Examiner is actually not interested in any of these. He's just interested in the selection. So that's plus 36x minus 4x minus 9. Adding these two, we're getting positive 32. And multiplying these two, we're getting negative 144.
Okay.
Okay, so G part. What would be the midterms?
15x and plus x.
Very good.
3x squared plus 15x plus x plus 5.
H part. 8x square plus 2x minus 1.
So 8x squared plus 4x minus 2x minus 1.
Very good. I part. This is 2x square minus x minus x.
2x squared plus 4x minus 3x minus 6.
A little disagreement. Look at this. Are we getting negative x when we add this?
Mm-hmm. Oh, no, not negative.
Not negative. So we'll change it. And we will use minus 4x
Plus 3x.
plus. Okay. Both the conditions need to be fulfilled. J part. 2x square plus 9x plus 9.
So 2x squared plus 6x plus 3x plus 9.
Very good. Three x square plus 2x minus 16.
Three x squared plus 8x minus 6x minus 16.
8x minus 6x. Very good. This is 10x square minus x minus 3.
So 10x squared minus 5x plus 6x minus 3.
I disagree.
Oh, yes.
This is not fulfilling both the conditions.
It doesn't equal -1, so 6x minus 5x, no. 5x minus 6x. Yes. Yeah. So 10x squared, 5x, yeah, plus 5x minus 6x.
Now this is correct. So we're getting -30 when we multiply, and we are getting -1 when we add them. Now this is correct. 5x square plus 6x plus 1.
5x squared plus 5x plus x plus 1.
5x square plus 5x plus x
X.
plus 1. Correct. 2x square minus 19x plus 9.
Yeah, 2x squared minus 18x minus x plus 9.
Very good. Very good. Okay, this is 12x square plus 8x minus 15. I'm also thinking for this.
12x. Sorry?
I'm also taking time to think.
12x squared plus 18x minus 10x minus 15.
That's so negative 180 and adding both of them. Yes, very good. Okay. So these are just worked examples. Now it says now go back to access this. Try factorizing the expressions using this new method. We don't have to go back, we just did. Factorize completely, you may need to remove a common before factoring. Okay. You cannot see anything common until F. So part A is usual, B is usual, C is usual, D, E. When you look at F, there's a possibility that we can take out common. For example, 6x square minus 38xy plus 40y square. We can also solve this without taking out common, like 6 into 40 is 240. We can solve for 240, but that's a large number. So if I just take out
2.
2 as common, very good. So that is 3x square minus 19xy plus 20y square. So they are a little with smaller numbers now. So 3 into 20 is 60. So we need to work out for 60. So 4 and 15. 3x square minus 4xy minus 15xy plus 20y square. So 2 stays outside. We're taking out common x. So 3x minus 4y. Then we take out common, that is minus 5y. So 3x and 5, 4 times is 20 minus 4y. And last step, 2 into x minus 5y into 3x minus 4y. If we won't have taken out 2 as common, we will be having one of the expressions. Maybe it would be 2x minus 10y into 3x minus 4y, and then we'll be taking out 2 as common. Or else the other one would have been double, and still we'll take out 2 as common.
Okay.
It is not necessary.
But it makes it easier.
Yeah, but we both know that we'll be having calculator in exam.
Yeah.
Let's look at G part. It says 6x squared plus 7x plus 2. I just thought that I could take out common. That was I part. After this, we go for I.
Okay.
It's 2
So
times this.
6x squared plus 4x plus 3x plus 2.
Very good. I part. And let's try it without taking out common.
Okay.
Or you just do it as you wish. I'll try without taking out common.
Okay. Okay. X minus 8 and x minus 5.
And 3 outside.
And the outside.
See, I didn't take out common.
Mm-hmm.
Then I had the
Add the 3. Okay.
at the end.
And then add the 3 as well. So
Mm.
3 and then x minus 8 and then x minus 5.
That's right. J part. Now this is an extended question. First, we'll have to convert it into quadratic. X plus 1 whole square minus 5 into x plus 1 plus x. Applying algebraic formula, a square plus 2ab plus b square minus 5x minus 5 plus 6. 5, 2 minus 5 is minus 3x plus 2.
So x squared minus 2x minus x plus 2. Yes. And then factor.
Final statement. Final statement is x minus 1 into x minus 2.
Mm-hmm. Okay.
Are you getting this?
I wasn't finished yet, but let me see.
And be careful when we reach this stage, that in the first two, I can clearly see that we have to take out x as common. And in the second, I took out minus 1 as common in order to get these two brackets as same sign.
Okay. So x minus 2. So x minus 1 and x minus 2.
Yes. K part. 2x plus 1 whole square minus 8 into 2x plus 1 plus 15. Are you trying this?
Yes. So x minus 1, x minus 2, and outside of it 4. Yeah.
Very good. Very good. Okay, let's see. What do we have next? Algebraic fractions. Okay, this is simple algebra. So we just have to simplify numbers with numbers, variables with variables. As we can see, 3 and 6 goes with each other. 3 1 times, 3 2 times, that's x by 2. Now in B part, I can see 2 y's in the numerator and 5 y's in the denominator. So 3 are left. So this is 1 over y cube. Then 12 and 16, 4 3 times, 4 4 times. These are 3. 3 goes away, 4 is left behind. So 3 over 4p4. Now this is the fun part. We were dealing with one of the quadratic equation. Now there are two. X square minus 4x plus 3 divided by x square minus 7x plus 12. Now what will we do? We'll solve them simultaneously and then eliminate any same factor. So this is x square minus 3x minus x plus 3 in the numerator and x square. So 6 and 1, no, 12, 3 and 4, minus 4x minus 3x plus 12. I'm getting minus 4 plus 3, I'm getting minus 7 and plus 12. So taking out common in numerator is x minus 3 minus 1 x minus 3 over x common x minus 4 minus 3 common x minus 4 x minus 1 into x minus 3 and in the denominator x minus 3 into x minus 4. Now we eliminate the same factors and we're left with x minus 1 over x minus 4.
Can we cancel out the x's?
No,
No, it
because
has.
there's a negative sign between them. You can only cancel out when they are being multiplied.
Okay.
Or divided.
And what
Short
about
example.
-1 and -4? Oh
No,
no,
we
we
can because there's negative sign. See, 2 plus 3 divided by 2. We cannot cancel out these 2's because that's 5 by 2, which is 2.5. If someone does that, 2 plus 3 by 2, they'll be getting 3.
also as part of an equation, then we can't simplify it.
Or else,
No,
if
that's
we
not
say this
possible.
is 1, 1, they may be getting 4, which is entirely wrong. So whenever we have this positive sign, we cannot do that. But yes, if, for example, we have 4x plus 8 divided by 2, I cannot cancel out this 4 and 8. But if I take out something common, which is 4, this is x plus 2 by 2. Now this 4 is being multiplied with the whole expression. So 2 one times and 2 two times. Final answer is 2 into x plus 2.
So if it's being added or subtracted, we can't do it.
We
But if
can
it's
do that.
multiplied, then we can do it.
So if it would have been 4x plus 7 over 2, this is my last step. There's nothing I can do.
Okay.
Or one more thing, if someone wishes to, that is 4x by 2 plus 7 by 2, splitting them up. So 2x plus 7 by 2. But we cannot cancel them out.
Okay.
Okay, these are easy. This is x by 2. Then this is y by 4. This is something related to the worksheet, if you remember, indices.
Yes, I do.
So let's try these last parts directly.
Okay. So C?
Yeah, try C, 2C.
So just, I guess, 1 over 2.
Right, 1 by 2. D part,
Y over 2.
that's right. P part,
Uh, 5x over 1.
that's right. I'm only
Which is
writing
x, yeah.
H part,
3AB.
3B only. 3 B only. 3 B. 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 3
Oh, yes. B is the one being squared. So yeah, A would be canceled. So 3B.
Yes. I part.
D, D and E. So 2 over 3DE.
Over 3DE, that's right. J part.
J 1 over 4B squared.
1 over 4 B square, correct. Okay. Okay. I think these will be a bit lengthy. I'll share you so you can practice them in your free time.
Okay.
And let's see what else we have. I'll send you these.
Okay.
Okay, this is again the extension, the same questions. So if I just see 3 crosses out with 3, 2 crosses out with 8 with 4, and so this is x square over 4.
Yeah.
Try. Let's do this h part and copy that. Or it will be better if I take a screenshot.
To the power of 10. Oh.
Yes.
Minus 18t to the power of 19.
Mm, okay. So first of all, I'm going to find out similar terms, and before that, I'm going to see if I can cancel them out or not. And I can see that everything in the numerator is being multiplied and in the denominator as well. There's nothing added. Whatever is it, it is between the brackets. So I'm looking at this first one, x plus y raised to power 10, and I can find the exact same in the denominator. Any issues?
No.
Now I'm going for the second one, which is x plus y, and cancelling out with this, and I'm left with 2. Then I'm looking at that z minus t raised to power 4, and z minus t in denominator I can find that is 19. But before doing that, there was one more thing. Allow me to go in reverse. I'm erasing this. In the numerator, x plus y is actually at 3 places: 1, 2, and 3. So this is 10 and 1, 11, and 12, 13. So basically, this is 13 in numerator. Do we agree? X
Yes.
plus y raised to power 13. And in denominator, this is again 13.
So we can just cancel all of it out?
Yes. So all of these x plus y's Eventually, it would have been cancelled out when we'll see that we still have similar terms. But this was much easier approach. And then C z minus t. So this is 24 in numerator,
Mm-hmm.
and in denominator C we have 19 and 4, which is 23.
Three. So just one on numerator.
1 on numerator. So I'm cancelling out this power only and z minus t completely in the denominator. Now see z minus t. Okay,
Yeah.
this was also being cancelled. So only one is left. This one is left.
Okay.
So x plus y is done. X plus y done. X minus t done. X plus y only that. And now numbers. Before doing that, I'll just copy something. So make less messy. This is 3 by 18 times n by 12 z minus y into that's 108 into z minus t over 15. So variables are already there. So this is, I'm just using my calculator, 3 into 10 into 108. 3 into 10 into 108. I get 3240 by, this is 18 into 12 into 15. I'm getting 3240, exactly same. So either I use calculator, and because now I know that we're getting same, 3 1 times, 6 times,
So
5 2 times,
minus y is left.
1 times, 2 3 times, and 12 1 times, 12 9 times, 9 goes with this 3 into 3. So no numbers left. And in the numerator, we're left with z minus t, and in denominator z minus y.
Oh, I see. Okay.
But if even if you put these brackets, we have a negative sign between them, so we cannot cancel them out.
Mm-hmm. Okay.
So this was just lengthy. We just have to do it carefully. Okay. In similar way, let's try this G part. Okay, give it few seconds, then I'll join you. Have a look.
Okay, I
Okay.
did it. So I got z squared plus t squared over 4.
Is this what you got?
Yes.
Okay, let me quickly get it. This is 3 1 times, 3 6 times. 3 8 times 24. And with the variables x plus y whole square, and that's cube. So this goes away, and there's this 2 left. Then this 2 cancels out here. And this z square plus t square, and that's a square again. So basically, this is 1 by 2. Let me write it once. This is 1 over 8 z square plus t square whole raised to power 1 by 2. Any objection if I write 1 by 2?
No.
So z square t square, that's 2 divided by 18 times x square plus y square.
Wait, sorry. When I was first doing like the 3, like simplifying the 3, 24, and 18, I first simplified 3 with 18. So that's allowed, right?
3
So,
with 18, yes.
and then afterwards 6 and then 24, and I simplified the 6 with the 24, which gave me the 4. So that's allowed,
No,
right?
no, no, they are both in denominator.
Mm-hmm.
You'll
Oh,
have
so
to
we
calculate.
can't simplify. Okay. So we can't simplify them.
So
Okay.
24 into 6, you can write 144.
Okay. Yeah. 144.
Yeah. Same way, 8 into 18 is 144.
Mm-hmm.
So before I do that, I can see this half and this 2. If I cancel these out, I'm left with 1.5. So that is z square plus t square. 1.5 is 3 by 2 divided by 144 x square plus y square. If you want to keep the same shape, this 2 is in denominator. I can write square root z square plus t square whole cube over 144 into x square plus y square.
When I was doing it, I didn't think because I didn't think that you could like simplify the z squared with plus t squared with the z squared plus t squared just like squared. I mean like with the power of 2. So I didn't
Yeah,
know.
I
So I
didn't
didn't
do it directly.
know.
I didn't do it directly.
I know. So yeah, I didn't move them up either. So yeah, okay. I see.
So that means we'll also add some of practice of this part as well.
Mhm. So
Like
question,
this is
sorry?
the high time. This is the high time we are not sitting in an exam. So we have time to practice.
So it's question 2, question 4, and question 5, right?
Yeah, I'll just clip them out and share
Okay.
with. Okay. Then this would be, I would say, entirely different because now we'll be dealing with LCM of variables. Hopefully, I think you know them, but that's a
Mhm.
totally different practice. We still have time. We can do some more practice. Hmm, let's select one of the questions from these. I'm trying for F.
Okay.
So this is y cube plus y4 divided by y square plus 2y plus 1.
Well, firstly, we can add the y3 and the y4 to make y7 at the numerator. But
And the examiner would do this as first thing. You thinking why?
yes, why would that mean?
Cube multiplied by y4 is y7.
Oh, so it can't have, okay.
What you can do is
Yeah,
1 plus y. So
okay.
that is why I didn't jump on the next exercise, because that was addition and subtraction. What we are currently dealing with is multiplication. Next exercise is addition and subtraction with fractions and LCM. So I don't want to pile that up.
Okay.
Okay, so in the numerator, I can see this is y cube into 1 plus y. And in the denominator, I'm going for middle term breaking. And that is y square plus y plus y plus 1. Y cube into 1 plus y. Denominator y into y plus 1 plus 1, y plus 1. Numerator is 1 plus y. Denominator is y plus 1 into y plus 1. So we can cancel out this y plus 1 with this y plus 1. And your final answer is y cube
Y3,
by y plus 1.
1. Okay.
Okay. Try key part.
K?
Yeah, 4k. X square minus 9 over x square plus 5x minus 24. Take the lead. I'll start in 10 to 15 seconds.
Mhm.
I hope you would have done it almost half. I'm joining in.
Yeah. I'm stuck at this part, so it's basically at the top numerator it's still x squared minus 9, and then at the bottom is x minus 3 and x plus 8.
I was
So,
thinking that I'll give you an hint that is a square minus b square. So this is actually a square minus b square like this.
oh, so I could like this.
So when it is a square minus b square, I can write it as a plus b and
Mm-hmm.
a minus b.
Yeah. Over x minus 3, x 8. So that cancels. So it's x plus 3 over x plus 8.
Yes.
Mm-hmm.
One more common mistake which I want you to discuss right here. When we have x plus 3 and x minus 3, and in the denominator we had x minus 3 and x plus 8, we always cancel out the same terms. Sometimes students confuse it with this. Suppose we have x square plus 2x minus 7 minus 2x plus 9. We cancel out the different terms, right? That
Yes.
was positive and negative. So they just confuse this with plus 3 and minus 3 numerator. I hope
Um,
you have that confusion. So
okay.
we always cancel out similar terms when we divide, and when we are adding only, then we cancel out the opposite terms.
Okay. Okay. We have to cancel the same terms.
When we are dividing, yes.
Yes. Okay.
Okay, let's try this F part. Let me take a screenshot. I'll send you homework in like few hours, but tonight,
Mm-hmm.
definitely, because battery is getting a little low and I'm actually outside.
Okay.
Okay, try this. Now, do you know what we have to do with this division sign?
We have to flip the 12
Very
a
good,
minus b squared and then a plus b.
very good,
Reciprocal.
very good.
Mhm.
So this is 3 into, or in fact, what could be simplified? We can do that. A plus b with the square. So 3 into a minus b over a plus b. And then that's a flip. A plus b over 12 into a minus b whole square. Are we getting same answers?
Yes. 1 over 4a minus b. Should we
1 over.
also like put the 4 into the bracket? Or can we just leave it like that?
We'll leave it like that because this is considered the simplified form.
Okay.
1 over 4a minus 4b. If someone does that, that's no harm. Both are correct.
It's just an extra step and unnecessary, so we can
Yes.
just do that.
That's right. One last question. C part. When we have all these multiplications, this is a very fun part. We can cross out many things throughout. During exam, that's a personal choice. I have this habit to rewrite the question so I don't spoil the original one. If I make a careless mistake, I can always see what
Refer back.
the question was.
Mhm.
So 9 1 times, 9 3 times, 3 1, 3 3. Again, 9 1 times, 9 3 times, 3 1 times, 327, 3 1 times, 3 9, 3 3 times, 3 4 times. And I think I'm done with numbers. I'll just copy to make it less messy and avoid careless mistakes. This is 1 over 1, x square over 4y cube, 3 over 1, and y square over x cube. I'm going to deal with variables. So I have only y square in numerator, so this cube goes away. X square in numerator, so this cube goes away. And finally, left with in the numerator that's 3, and in the denominator 4yx or 4xy. Got it?
Yes, 4 on the bottom. X 3. Okay.
I'll share the practice questions with you
Mm-hmm.
today.
Okay.
Anything you would like to ask or you want me to repeat?
No, nothing.
See you in next class. Take care.
Okay, thank you. Bye.
Bye.